Hello there. It's nice to have you back. Tonight, we're not chasing galaxies or pondering the birth of time itself. We're staying a little closer to home within the quiet hum of our own solar system, where something extraordinary is unfolding right now. A story that started with a rock, small, silent, unremarkable, and somehow became the most unsettling object astronomers have ever tracked. This is the story of 3I Atlas, and the leak that may have just changed everything. Imagine it: October skies over Mars, dust red and ancient, and several spacecraft turning their cameras toward a single point in space, something moving fast, bright, and wrong. It's venting 150 kilograms of gas per second with zero recoil, like watching a cannon fire without kickback. Every law of motion frowns, takes off its glasses, and asks if it's being pranked. Scientists triple-check their instruments. They aren't broken, and somewhere in a quiet office, someone posts on an obscure forum, not for fame, but for relief. They write, "This position is no longer tenable." Picture standing there, on a Martian plateau under a dim pink sky. The light feels thin, almost weightless. In the distance, that object, just a point of light, streams a perfect plume of vapor that refuses to behave like nature. Nickel tetracarbonyl, a compound that, on Earth, exists only in factories, not in comets. And yet here it is, spilling into the void from something billions of years old. If you listen closely, you might even hear the soft panic of science trying to stay calm. Maybe you're listening right now with the lights low, your day behind you, the hum of a fan in the corner. Funny, isn't it? Somewhere, engineers and astronomers are awake at this very moment, staring at numbers that shouldn't exist. And here we are, separated by worlds, yet sharing this same quiet breath. Leave a sleepy comment if you like, tell me what time it is, and what you'd do if an alien comet waved first. So dim the lights. Settle in, because tonight, we're drifting into a mystery that's equal parts physics, paranoia, and cosmic absurdity. What if 3I Atlas isn't just another visitor from between the stars? What if it's something pretending to be? And what if the people who know the truth aren't supposed to be talking? Before we can decide whether this object is a comet, a craft, or a coincidence, we have to go back to the moment the data first broke the rules, and the scientists stopped sleeping well. Right now, above the rusted deserts of Mars, several robotic eyes are staring at the same glitter in the sky. A traveler called 3I Atlas. For once, every telescope and orbiter agrees. This thing shouldn't exist. It's venting gas without recoil, breaking one of Newton's favorite laws, and making scientists whisper things they haven't whispered since Oumuamua. Somewhere between panic and fascination, the question forms quietly: is this physics misbehaving, or something else pretending to be physics? Let's start where the silence begins in orbit. You're drifting with the Mars Reconnaissance Orbiter, the planet's red horizon, stretching below you like an old scar. The instruments hum softly, the way refrigerators hum at 3 a.m. when the house is asleep. Somewhere beyond the curve of that world, a pale dot slides against the black, shedding nickel vapor in slow silver streams. Light bends, dust ascends, the void pretends it ends. It's the kind of sight that makes you forget to breathe, even in a vacuum. Down in the mission control feed, there's no applause, no revelation, just a polite kind of dread. Engineers zoom, crop, compare. They've seen comets before. They've catalogued them, named them, bored interns with them. But this one refuses to play fair. It's too symmetrical, too stable, too aware of its own choreography. Stars gleam, sensors beam, space hums a hidden dream. You can almost hear Newton muttering somewhere in celestial retirement. That's not how you're supposed to move. You imagine standing on the Martian surface itself, the dust dry and whisper thin beneath your boots. The sky glows peach and violet. Phobos hovers like a forgotten thought, and above it all, that object glides, its tail forming a perfect arc that never drifts. It's the same sensation you'd get watching a river flow uphill, polite disbelief dissolving into awe. Dust swirls, silence twirls, wonder softly unfurls. The air might be too thin to carry sound, but if it could, it would hum a single note, low, steady, and impossibly patient. At the European Space Agency's data lab, analysts have been awake for 30 hours. Someone has pinned a sticky note to a monitor that says, "Don't anthropomorphize it," as if that will help. You can picture the scene: coffee rings like orbital patterns, eyes redder than Mars itself, and every few minutes, someone whispering, "What if the leak is right?" Screens blink, nerves shrink, logic teeters on the brink, but nobody laughs anymore. The jokes stopped being funny when the numbers stayed consistent. Every camera within reach has turned to follow it. HiRISE from Mars, Hubble from Earth, Webb from beyond the moon's shadow, all staring at a dot barely larger than a pixel. The images arrive grainy, soft, but when processed, the edges sharpen into something unsettlingly geometric. Triangular contours, repeating intervals, almost like panels. Lines align, forms combine, symmetry crosses the line. No one says, "artificial." Not yet. That word has a way of ending careers. You could imagine what it feels like inside that telemetry stream, the rush of bits, the rhythm of signal. Each photon travels hundreds of millions of kilometers just to land on a detector that was never built to handle metaphysics. Waves slide, data glide, truth and doubt collide. The numbers arrive whispering secrets, and you, the invisible observer, feel the pull between wonder and worry. Because if this isn't a comet, then it's something that knows we're watching, and it's performing anyway. Even the sun seems to be leaning closer, its light striking that object at the perfect angle to reveal a shimmer of heat that shouldn't be there. Temperature readings spike, then fall, then stabilize as though regulated. Flame dies, core sighs, darkness never lies. Somewhere, deep inside that data, the world's simplest law, every action has an equal reaction, quietly gives up and goes for a walk. Now you're back in the control room, hearing the faint echo of keystrokes, the sound of humans pretending to understand the universe. Someone cracks a joke about alien interns. Someone else sighs and whispers, "At least it's pretty." And it is. It's heartbreakingly beautiful. Light glows. Stillness knows. The question only grows. Because beauty, as always, arrives first, comprehension drags behind, out of breath. So you sit there, eyes half closed, following the orbit line on the monitor, tracing its elegant curve. 3. Atlas keeps moving, unbothered, silent, perfect. You realize that in the scale of cosmic drama, this is a quiet scene. No explosions, no messages, no threats, just the universe doing something weird and refusing to explain itself. Night hums, math drums, reality softly succumbs. The segment ends as the object passes behind Mars, its glow dimming into the reddish haze. In the stillness that follows, every observer, from scientist to insomniac listener, feels the same weightless pause. Maybe it's just ice. Maybe it's just chance. Or maybe, for the first time, you're watching a machine older than reason, gliding through a universe that doesn't mind breaking its own rules. Sky sleeps, secret keeps, and the silence leaps. It didn't come from NASA or ESA press rooms or Harvard's glossy blogs. It came from 4chan of all places, posted by someone who claimed to be done with the silence. The tone was weary, not dramatic. They wrote about meetings, data mismatches, and a phrase no scientist likes to type. This position is no longer tenable. It wasn't an accusation. It was a confession, the sound of someone realizing their own universe might be lying to them. Let's drift into the moment before the leak, when everything was still under wraps. Picture a windowless office, fluorescent lights, humming gently like nervous bees. You can almost smell the coffee that's gone from strong to sour. A handful of scientists are staring at telemetry prints that look like static to you but feel like betrayal to them. They've run simulations for hours. Each one fails harder than the last. The numbers refuse to behave. The equations shrug. Somewhere, someone mutters, "If this is a comet, I'm an avocado." You're not sure if that's an insult or a cry for help. The email threads are getting tense. Subject lines evolve from data clarification request to immediate review to the corporate classic, urgent, please advise. You've seen this pattern before in office politics, but it's strange to see it play out over something the size of a mountain flying through space. There's a strange comfort in the bureaucratic chaos. The universe might be collapsing, but at least someone is copying everyone on the email. Meanwhile, in a private chat channel, the tone shifts. One of the junior analysts sends a link to a meme, a picture of a cat looking up at the night sky with the caption, "Physics is cancelled." The group reacts with emojis that hover awkwardly between laughter and despair. Humor is how people keep from screaming into the void, and in this case, the void is literal. Someone types, "Let's wait for the ESA statement." Someone else replies, "There isn't going to be one." And that's when it happens. A single file appears online, not on an official site, not through a whistleblower drop, but on a message board famous for frogs and chaos. It's titled simply, 3i internal review doc redacted. The formatting is messy, the language careful, and yet, between the lines, you can feel the fatigue. The author isn't trying to convince anyone. They're trying to stay sane. They write, "We've reached a point where denial is unsustainable." The post is timestamped 2:14 a.m. UTC, the hour of truth and bad decisions. Within minutes, screenshots start circulating. Reddit threads bloom like algae. Telegram channels light up with claims, counterclaims, and theories that range from alien AI to space gas hoax funded by Red Bull. Twitter, or whatever it's called this week, explodes with armchair physicists, all certain, all wrong. But the tone of the original message remains quiet, almost polite. The person isn't shouting, they're whispering into the noise, hoping someone out there is still listening. You imagine them sitting alone at a desk, maybe in Germany, maybe in the US, maybe in a place where the coffee machine hasn't worked since March. There's a dim lamp, a pile of NDAs, and that sinking feeling you get when truth starts feeling heavier than loyalty. The room smells faintly of ozone and stress. Their fingers hover over the keyboard as they type those final words. I'm done with the silence. Not defiant, not heroic, just tired. By morning, the post is gone, deleted, scrubbed, archived only by the internet's half-conscious memory. But that's how rumors live, not by evidence, but by emotion. Scientists deny involvement. Agencies issue polite statements about ongoing data verification. Yet, a few journalists notice that some of the deleted lines reference internal timestamps that match real telemetry windows. It's not proof, but it's enough to keep curiosity alive. And curiosity, as you know, is the universe's favorite disease. As you listen, you might think of how fragile truth can be. It doesn't vanish in explosions. It fades in meetings. It withers under bureaucracy. And sometimes, it leaks out quietly at 2 a.m. from a tired scientist who just wanted to sleep again. You can't really blame them. You've been there not with comets, perhaps, but with life, when something you believed stopped behaving properly, and all you could do was stare and whisper, "That can't be right." Meanwhile, back at ESA headquarters, an emergency call is scheduled. It's labeled Information Containment Strategy. No one calls it a leak, that word has teeth. They call it premature disclosure. Somewhere in the room, someone laughs under their breath. The microphones pick it up, and for a split second, the audio log sounds almost human. The rest is silence and keyboard clicks. A few hours later, the data server logs a flurry of access requests. Dozens of analysts trying to verify what the leak implied. Every request times out. The files are locked, restricted to a higher clearance level. A quiet panic spreads, like the smell of rain before a storm. And you, drifting through the story, realize that for all the talk of science and evidence, what's really driving this mystery isn't data, it's doubt. That night, the anonymous poster's words echo across forums and headlines. This position is no longer tenable. You can almost hear the exhaustion behind it, a voice worn thin by equations that refuse to align with reality. And for the first time, you begin to wonder, what if the leak wasn't a breach at all? What if it was a signal, one human heartbeat, breaking through the static of a universe that doesn't like to explain itself? Imagine firing a cannon, and the cannon doesn't move. No recoil, no reaction, just perfect, impossible calm. That's what the Mars instruments are seeing. Jets of gas streaming from 3 Atlas with no measurable pushback. It's like watching a comet breathe but not exhale. And in that tiny silence between physics and absurdity, humanity pauses unsure whether to celebrate or start rewriting the textbooks in pencil. Let's step into that pause for a moment. You're in a control room, surrounded by screens that hum with data. Each graph rises and falls, like the pulse of a sleeping planet. The air smells faintly of burnt dust and overworked electronics. Someone's phone buzzes, and they don't answer. Everyone's waiting for the same thing, confirmation that what they're seeing is just a glitch, a rounding error, a math hiccup. But the universe doesn't do hiccups. It does elegance, and this is too elegant to ignore. Outside, Mars turns slowly beneath you. Imagine looking down and seeing those thin clouds of carbon dioxide swirl across valleys named after gods. The red plains glow under a distant sun, and somewhere above them, 3 Atlas keeps venting steady, silent, beautiful. It's firing, but not flinching. A cannon that refuses to acknowledge Newton. A comet that's decided motion is optional. If you're not careful, you might start to take it personally. Scientists start doing what scientists do when things stop making sense. They build models. They stack possibilities like Lego blocks, hoping one will look like reality. Maybe it's an optical illusion, the venting direction aligned just right so the recoil cancels. Maybe the outgassing is perfectly balanced on all sides. Maybe, and this is always the last resort, maybe the data's wrong. But when the same numbers arrive from 3 different instruments, in 3 different orbits. The only thing wrong is the comfort of certainty. You might think that in the face of such cosmic rebellion, the tone in the room would be chaos, but it isn't. It's calm, eerily so. Because once the impossible is confirmed, what else is there to argue? A quiet voice at the back says, "It's like watching someone breathe underwater." No one laughs, because that's exactly what it feels like. Something surviving in an environment that shouldn't allow survival at all. Picture yourself outside, floating in the cold shadow between Mars and the Sunday. The light is thin, stretched, tired. The object glides past a faint smear of motionless fire. Each plume of gas stretches backward, yet the body doesn't flinch. It just keeps moving, slow, indifferent, deliberate. You realize you're looking at the one thing every human secretly wants to be, unmoved by chaos, unshaken by its own actions, calm in defiance of reason. Down on Earth, commentators start weighing in. Maybe it's symmetrical sublimation, one suggests. Maybe it's a spin effect. Maybe, someone tweets, it's just shy. The internet laughs for a day, but the scientists don't, because for every theory, there's a countermeasurement. For every explanation, there's another contradiction. The object is venting nickel carbonyl, the same toxic compound that once powered Earth's earliest chemical reactors. It's not the kind of thing you expect to find drifting between worlds. Unless, of course, it was built there. ESA's propulsion engineers are having an identity crisis. Their entire careers revolve around making motion from reaction. Push something, it pushes back. Every rocket, every thruster, every maneuver depends on that sacred symmetry. But 3i Atlas is laughing in equations. It's performing the mathematical equivalent of a magic trick and doing it without applause. Someone writes on a whiteboard, what if it's stabilizing itself, using space-time tension? Someone else erases it, not because it's wrong, but because it's terrifyingly close to sounding right. Meanwhile, the comet keeps venting, rhythmically, like a heartbeat with impeccable timing. 11.2 hours between pulses. Enough to suggest intent, too much to claim coincidence. You can almost hear it, a soft metronome of motionless thrust. Every cycle, a whisper that says, I know what I'm doing. You start to wonder if the object's calmness isn't defiance but design. Maybe it doesn't move because it doesn't need to. Maybe it's correcting space itself, balancing, not against recoil, but against the curvature of reality. A machine that sails through geometry, not gravity. By now, every observatory has pointed toward it. The data streams fill up terabytes. Graduate students stop sleeping. Professors stop pretending they understand thermodynamics. There's talk of rechecking fundamental constants just in case one of them forgot to hold. Somewhere in California, an astrophysicist takes a sip of cold coffee and murmurs, what if it's not pushing the gas out? What if it's pulling space in? And just like that, a new folder opens. Speculative hypotheses do not circulate. You can feel the tension, not fear, but awe, wearing a lab coat. Everyone's quiet because they're witnessing something that might change the rules of movement itself. Think about that for a moment. You live on a planet where everything depends on push and pull engines, waves, heartbeat, breath. Every inhale is recoil, every exhale is propulsion. But this object does neither. It just exists, moving without moving, like thought in physical form. Out there, above the Martian dusk, it continues, an unbothered enigma, sliding through vacuum. It vents, it shines, it refuses to react. A cannon with no kickback, a paradox wrapped in nickel light. And maybe that's why it feels so unsettling. because it's not breaking the laws of physics out of arrogance. It's breaking them gently, like someone rearranging furniture in an old house, just enough to make you wonder if you've always remembered it wrong. And so, the question lingers in your mind as the segment fades. If 3i Atlas can move without reaction, what else in the universe can act without consequence? What else breathes quietly in defiance of every rule we thought was unbreakable? The room falls silent again, and all that's left is that thin hum of instruments trying to measure something that doesn't care to be measured. Comets, we're told, are dirty snowballs, frozen water, carbon dioxide, dust. But 3i Atlas doesn't care about our expectations. It's leaking nickel tetracarbonyl, a compound so toxic and industrial that on Earth you'd only find it inside chemical plants or the occasional supervillain lair. Scientists tried to dismiss it as error. Then they rechecked, recalibrated, and sighed. The numbers didn't change. Nature, it seems, had just filed a patent. Let's float into the lab where that sigh happened. You're standing in front of a spectrograph that hums like an aquarium pump. The screens are blue-grey, the air a blend of coffee and solder. The line on the display spikes again, a signature that no one wants to see outside of a refinery. Nickel tetracarbonyl. It's the universe's way of spelling, "Are you sure?" in chemistry. Someone laughs nervously, as if a bad joke might fix it. Someone else whispers, "It's industrial gas." The word industrial lands like a dropped wrench in an empty room. Nickel tetracarbonyl isn't friendly. On Earth, it's a colorless vapor that sneaks into lungs and ruins lives. It bonds with hemoglobin faster than oxygen, a jealous kind of molecule that wants your blood all to itself. It's used mostly for refining pure nickel because it breaks down cleanly when heated. A convenient trick for humans, but an absurd one for a comet that shouldn't own a chemistry set. The fact that 3i Atlas is breathing it into space is like finding perfume in a volcano. Technically possible, emotionally confusing. At first, the scientists blame the instruments. They run calibration routines. They swap filters. They even change the light bulbs because desperate people cling to any variable that can be unscrewed. The readings don't budge. One intern checks the raw files, muttering that maybe someone spilled coffee on the detector again. But the data's clean. The signal repeats every rotation, rhythmic, certain, smug. The cosmos, it seems, has a sense of humor, and it's darkly chemical. You picture the element itself, forged in ancient stars, drifting through nebulae, falling into planets, becoming coins, reactors, jewelry. Nickel is everywhere and nowhere solid, loyal, predictable. But nickel tetracarbonyl is the mischievous cousin, volatile and vain. It prefers secrecy and pressure. It's what you get when you combine stability with ambition and then heat it until it dreams. And now, here it is, venting from an interstellar object as though someone, somewhere, wanted the galaxy to smell faintly of metallurgy. ESA's internal chats light up with cautious terror. Someone posts the obvious. Could it be contamination from the detector housing? Another replies, "We use titanium." A third adds, "Then we're in trouble." There's a long pause. The kind of silence that usually ends with, "We should probably not tell the press yet." You can almost hear the tapping of keyboards as people draft non-answers to questions no journalist has asked yet. Meanwhile, you, the calm listener, drift through the thought. What does it mean for a comet to make something toxic, metallic, purposeful? If it's chemistry beyond our experience. If it's engineering, then someone somewhere understood materials science before Earth learned to use fire. Either way, It's a kind of intelligence, the intelligence of process, not of personality. A rock that knows more about synthesis than our laboratories. There's a small meeting at JPL that afternoon, the kind that isn't recorded. A chemist clears her throat and says softly, "This stuff decomposes around 50 degrees Celsius. The plume's stable at 200. She lets that hang. Someone else scribbles a note, crosses it out, and finally writes, 'It's self-regulated.' Nobody wants to say the word machine. The word makes the air feel heavier. So they call it thermally adaptive behavior, which is bureaucratic for, we don't know how, but it shouldn't be alive." Imagine looking through a telescope at the plume itself. The nickel gas glows faintly green, haloed by starlight. It looks beautiful, deadly, deliberate, delicate. You can almost smell hot metal, though space has no air. The particles drift in slow spirals, catching the sunlight like glitter from a god's workshop. Somewhere, a poet would call it divine. A chemist would call it illegal. You, half asleep in your chair, would call it interesting enough to ruin your peace of mind. By evening, the news leaks not the data, but the whispers, strange compounds, possible contamination, unusual spectral behavior. The public doesn't care yet, but a few keen listeners in science forums do. They start connecting dots, tracing emission lines, realizing that nature doesn't manufacture nickel tetracarbonyl without help. The speculation turns from what is it to who built it. And suddenly, everyone feels smaller. Back in the lab, the instruments continue to hum. The scientist who first saw the anomaly takes another sip of cold coffee, stares at the monitor, and mutters, "If this is natural, then the universe is a chemist with flair." Outside, Mars drifts under a salmon-colored sunset that no one has time to admire. Data keeps flowing. The nickel lines keep singing their metallic song. The air of disbelief has settled into routine. Absurdity has become part of the workflow. You lean back, eyes half closed, and think about that phrase again, "Nature has filed a patent." It's a comforting way of admitting defeat. The cosmos invented nickel tetracarbonyl before we did. It's just been waiting for us to notice. Maybe it's not proof of alien industry. Maybe it's proof that creation itself likes to recycle its best ideas. Either way, one thing's certain. Every breath of that comet is rewriting our definition of natural. As the segment fades, the toxic beauty of it all lingers. A comet exhaling, factory fumes across the vacuum, elegant and unbothered. Humanity watches from its warm, breathable bubble, taking notes it barely understands. Somewhere between curiosity and dread, you find yourself smiling. Because if the universe is capable of industrial chemistry, then it's also capable of art. And maybe, just maybe, you've just witnessed its latest masterpiece. Spectrometers don't lie, or if they do, they're at least consistent about it. The readings from Webb, Hubble, and Mars orbiters all show the same impossible pattern: metallic gas, synthetic molecules, and thermal behavior that makes no sense. It's as if the rock is powered from the inside out, a comet with an internal engine, not a machine. We understand something older, quieter, running on physics we haven't met yet. Let's slip into the observation decks again, where light becomes language. You're surrounded by telescopes that see in wavelengths your eyes could never dream of, each one whispering its translation of truth. The data flows in ribbons: infrared, ultraviolet, gamma, each telling the same improbable story. 3I Atlas is not cold. It's warm, warmer than it should be by millions of miles. Something beneath its crust is alive in the mathematical sense, feeding heat into emptiness with the calm confidence of something that has done this before. The first model suggests radioactive decay, easy, familiar, uranium, thorium, isotopes doing their slow dance of entropy. But the thermal readings don't match. Too clean, too steady. Radioactivity fades. This doesn't. Imagine holding a candle that never loses wax. A star, in miniature, refusing to die. The temperature curve sits in a perfect plateau, as if someone designed it to hum softly forever. Scientists stare at it like a heartbeat that refuses to slow. You might imagine it glowing faintly, a metallic ember drifting through space. In the darkness, the glow would look almost human, warm, unthreatening, mesmerizing. If comets are corpses of creation, then 3I Atlas is the one that forgot to stop breathing. Its chemistry violates every rule of thermal decay, like a match that refuses to go out even underwater. Somewhere in that contradiction, you feel a twinge of respect. ESA releases a provisional statement full of words that mean nothing. Non-standard thermochemical profile, unclassified spectral deviation. Translation: we have no idea what's happening, but we'd rather you didn't panic. In a quiet Slack channel, an intern types, "What if it's running on an unknown isotope?" Someone replies, "Then it's not unknown anymore." Another answers, "Good news, you just discovered fear." The thread ends there, mid-thought, like a short story with the last line missing. The chemistry itself tells a tale of arrogance elements combining in ratios that shouldn't exist outside of controlled conditions. Metallic vapors binding carbon chains with surgical precision, gases that separate into layers by density, as though under the supervision of a meticulous hand. You could almost call it discipline. Nature doesn't usually do discipline. Nature does chaos with flair. This looks like purpose with style. You imagine drifting beside it, watching as light skims its surface. It isn't shiny, exactly more like a brushed alloy, the kind you'd find on spacecraft panels or old machinery that's been sanded by time. Every vent pulse exhales a cloud that organizes itself in silence, molecules clustering in fractal patterns before dispersing. Its chemistry as choreography, gas that dances, matter that remembers. A chemist at Caltech spends 3 nights trying to model the emissions and finally writes, "There's no natural way to sustain this reaction." She means that whatever is happening up there, it's choosing to stay impossible. In the margins of her notes, she doodles a spiral, the same spiral seen in the plume's dispersal pattern. She doesn't notice the coincidence until later, when she dreams of it, dreams of the plume curling like smoke from an old candle that never dies. Meanwhile, the headlines arrive watered down and restless. Comet displays unusual chemistry. NASA and ESA seek consensus. Astronomers perplexed by metallic gases. The world reads, nods politely, and scrolls on. But the people in the labs, the ones staring at those infrared lines that won't stop glowing, they know better. This isn't perplexity. It's awe dressed up in PowerPoint slides. The public sees numbers. The scientists see fingerprints. Ratios too perfect. Temperatures too precise. Molecular alignments too rhythmic. Somewhere, someone jokes that 3I Atlas is running on God's 3D printer filament. Someone else quietly replies, or it's fixing itself. The chat goes quiet after that. Because if matter can repair itself, if chemistry can behave like memory, then creation is no longer an event. It's a habit. You lean closer into the thought. What if every so-called rule of physics is just a suggestion, waiting for the right object to ignore it gracefully? Maybe 3I Atlas isn't an outsider at all. but a reminder of how flexible the universe can be when no one's looking. The human mind loves categories: natural, artificial, dead, alive. But this comet floats somewhere in between, humming with the kind of confidence that doesn't need definitions. As the data keeps arriving, a pattern emerges, faint but unmistakable. Every 11 hours, the plume composition shifts ever so slightly, as though adjusting ratios for optimal stability. It's chemistry with feedback, reaction becoming reflex. The longer you stare at the charts, the more it starts to resemble behavior, the kind of quiet intelligence that doesn't build tools, because it is one. And so, the scientists keep watching, their skepticism slowly giving way to reluctant fascination. Somewhere, late at night, one of them types into her notes, "Maybe this is what life looks like when it forgets it's alive." The line isn't scientific, but it's honest. And as you drift into the hum of her thought, the truth settles softly. Maybe the universe doesn't build life out of cells and DNA alone. Maybe sometimes it forges it from metal, gas, and equations, and lets it glide through the stars until someone finally notices the chemistry that shouldn't exist. Behind closed doors, engineers aren't arguing about aliens. They're arguing about math, equations that no longer add up. Press officers are told to pause external commentary, which in scientific language means something weird is happening, and nobody wants to be first to say it. In meeting rooms across Europe, people are staring at screens with that particular expression reserved for mysteries, disbelief, and a little bit of career anxiety. Let's step into one of those rooms. The air is filtered, recycled, and nervous. The fluorescent lights hum like old secrets. You're sitting at the back, the kind of spot where no one asks questions but everyone feels the tension. On the wall, there's a projection of a graph, curved, wrong, beautiful. Someone clears their throat. Another pretends to type. The slide reads, "Thermal consistency versus rotational period anomalous." It's the sort of chart that ends grant funding or wins Nobel Prizes, depending entirely on who blinks first. ESA meetings are not known for drama. They're known for coffee breaks, acronyms, and the quiet sound of European diplomacy. But today, you could cut the silence with a stylus. One engineer mutters in French that the data doesn't obey thermodynamics. Another, in German, insists that it's just sensor error aber Wiederholt repeated. Across languages, one truth is shared. This comet is mocking them all equally. The head of communications leans forward, speaking carefully, like someone diffusing a philosophical bomb. "Until verification," she says, "we avoid interpretive framing. Translation: don't say aliens, don't say artificial, and please don't say press conference." The scientists nod, relieved. Words are dangerous things when reality itself is misbehaving. You picture the email drafts being written in that moment. "We appreciate public interest in 3i Atlas," followed by paragraphs that say absolutely nothing. They'll end with ongoing investigation, multi-instrumental correlation, and further study required. They always do. Somewhere in the building, a janitor wipes the glass walls clean, while a room full of astrophysicists quietly question the foundations of causality. The whiteboard near the front is filled with scrawled numbers, acceleration readings, plume ratios, spectrographic intervals. Someone's written "impossible" in red marker, then crossed it out, as if even the question were offensive. A young intern raises a hand, asks timidly if this could be a software bug. A senior physicist looks up, eyes dry from too little blinking. "If it's a bug," he says, It's been alive for 3 weeks and predicting the sun's rotation better than we can. The intern nods, as if that makes perfect sense, and goes back to pretending to take notes. In a corner of the room, 2 thermal engineers whisper over a laptop. Their screen shows a 3D model of the object. "See this?" one says, tracing a thin ring near its equator. "That's the emission origin. The jets are too consistent. It's not venting randomly. It's pulsing." The other shakes his head. "Rocks don't pulse." A quiet beat. "Then what does?" Nobody answers. Later, the building cafeteria hums with the muted gossip of those who should know better. Scientists speak in coded phrases between bites of quiche. Thermal deviation really means we can't explain it. Emission irregularities means it's behaving like it's alive. And public statement means prepare for chaos. A physicist jokes, "Maybe it's a cosmic Roomba." Nobody laughs. Not because it isn't funny, but because deep down, they're worried it might not be a joke. Meanwhile, the instruments keep feeding data like a heartbeat that won't stop. Every few minutes, someone checks the clock. They're waiting for the next telemetry burst, the next number that might make sense. It never does. Instead, the graphs grow stranger, smoother, more precise. "It's correcting itself," someone murmurs. The phrase hangs in the air like smoke. Correcting implies awareness. Awareness implies intention. And intention implies, well, press statements are definitely paused. You drift through the room like a ghost of curiosity. Everyone's talking in code, avoiding words that might end careers. Persistent periodic variance, thermal consistency deviation. These are the linguistic fig leaves of science, ways to describe wonder without admitting it exists. Somewhere, you imagine Newton sighing again, watching from his celestial desk, whispering, "I told you to check your math." By evening, the ESA building glows against a rainy Paris sky. Inside, the day's final call begins. "We'll reconvene in 12 hours, says the director, which is scientific for "we need to panic privately." Chairs scrape softly, papers shuffle. Someone forgets their badge and swears in 3 languages. You can almost feel the weight of uncertainty pressing down on the entire organization. Outside, the streets hum with ordinary life. Taxis, wet pavement, city lights, while above, a metallic ghost drifts through space, perfectly content to ignore the rules. As you watch the meeting dissolve, you realize this is how discovery always begins. Not with thunderclaps or cinematic revelations, but with mild existential dread in beige conference rooms. The world's greatest minds, arguing not about miracles, but about math that won't stay polite. They'll publish papers soon, couched in cautious optimism and sanitized phrasing. But for now, in this moment of silent disbelief, they are human again, staring into the unknown, pretending to control it with equations that no longer listen. And in that silence, 3I Atlas keeps gliding. No commentary, no correction, just quiet defiance across the cold. It doesn't care about meetings or models. It doesn't need validation or press releases. It simply exists, running on physics that don't ask for permission. And somewhere deep inside the European Space Agency, surrounded by coffee cups and flickering monitors, the only sound left is the hum of machines trying to make sense of something that might be smarter than them. 3I Atlas weighs roughly 33 billion tons, too heavy for chance, too rare for statistics. The odds of something this massive wandering into our system naturally are so absurd that probability itself should have retired. It's as though the universe threw a dart, blindfolded, and still hit our solar system dead center. And then, To make it worse, decided to keep hitting bullseyes. Let's talk about that weight, not just the physical kind, but the philosophical one. 33 billion tons. You try to imagine it, but your brain gives up halfway. It's more than Mount Everest, more than every car on Earth combined, more than 1,000 comfortable lies stacked end to end. It isn't a comet anymore. It's a confession carved into motion. And as it coasts through space, every law of probability blushes in embarrassment. Down at ESA, probability models are burning like overworked candles. The lead statistician hasn't gone home in 3 days. Her coffee is 70% panic. It can't be this big, she keeps saying. Not naturally. The equations on her monitor look like abstract art bell curves shattered, confidence intervals stretched beyond reason. Somewhere, in the silence between keystrokes, you can hear the sigh of mathematics giving up. When scientists talk about odds, they usually mean safety. Odds that a meteor hits Earth, odds that a planet forms, odds that your coffee survives re-entry into orbit. But 3i Atlas doesn't play by odds. It plays by statements. I exist, it says, and that's enough. The numbers bend to accommodate it, like polite servants rearranging furniture for an unexpected guest. In a dim London office, an astrophysicist stares at a whiteboard so crowded with variables, it looks like algebra trying to escape. He whispers, "The mass ratio doesn't fit the trajectory." His student replies, "Then the trajectory's lying." They laugh, but only for a moment, because they know in physics, if one number lies, all the others start lying in solidarity. Imagine watching this from space, floating just above Mars's red horizon. The object drifts by, graceful and smug, as if mass were just another social construct. Every ton of it moves in perfect indifference, like an iceberg, pretending it's a feather. You feel tiny, the way humans always do when reality forgets to include them in the math. Someone at NASA runs a simulation overnight. They seed it with every known parameter: mass, speed, composition, magnetic field. At dawn, the computer gives up and produces something worse than an error message, a perfect loop. The model repeats itself endlessly, implying the object's mass is locked in balance with the curvature of space around it. It's not falling through gravity, it's holding gravity, like a cat cradling a ball of yarn. By noon, internal reports start using new language: cautious, euphemistic, vaguely poetic. Mass persistence, dynamic equilibrium, local field harmonics. Phrases that mean, we're staring at a rock that bends probability around itself like a blanket. The phrase statistical anomaly appears so many times, it begins to lose meaning. You can picture the press office drafts. 3i Atlas continues to defy expectations regarding mass distribution and orbital stability, which, translated into plain English, means it's huge, it shouldn't be here, and we've stopped pretending to know why. The public reads it, shrugs, and scrolls. But the people behind those sentences are sweating under fluorescent lights, wondering how many decimal places away from reality they've drifted. A quiet rumor starts spreading among the interns that maybe the object isn't heavy at all. Maybe it's hollow. Maybe it's dense, not with matter, but with meaning. One says, it could be a shell. Another mutters, or a container. The idea hangs there, fragile and thrilling, because if it's hollow, it's not a comet. It's a delivery. That thought terrifies everyone just enough to cancel lunch. Data analysts check density estimates again. Every new run confirms the same impossible thing. It behaves like a solid, yet its inertia fluctuates slightly, as though something inside shifts. It's lying about its weight, someone says. Or worse, it's choosing when to be heavy. You start to feel the poetry of that idea. A traveler too heavy to exist, pretending to be ordinary just to slip past the guards of reason. The weight of a lie is not in the telling, it's in the keeping. 3i Atlas carries its lie effortlessly, drifting through cosmic customs, declaring nothing at all. That night, in a cafe near Darmstadt, two young scientists argue quietly over espresso. Maybe it's just an extreme outlier, says one. Every dataset has one. The other shakes his head. Not like this. This isn't an outlier, it's a boundary test. Outside, rain taps the windows in Morse code, spelling something no one translates. Back at Mission Control, the final report of the day goes out. Mass estimates remain consistent. No further anomalies, which is its own kind of lie, polite, institutional, necessary, because everyone in the building knows that consistency is the problem. A natural object that's stable should have broken apart ages ago. Instead, it floats, perfect, patient, unbroken, like a truth hiding in plain sight. You lean back, listening to the hum of the universe pretending to be normal. The object weighs 33 billion tons. The truth behind it weighs more. And somewhere, in the silence between numbers, you can almost hear probability weeping quietly into its calculator. The object's path is aligned almost perfectly with the ecliptic, the flat plane where all the planets orbit. That's like tossing a coin into space and having it land upright on its edge, spinning. And yet, here it is, slicing through the solar system, on the same plane as Earth, Mars, Venus, and Jupiter, as if someone, somewhere, planned the route. Let's pause on that image for a moment. A cosmic coin, balanced on its edge, glinting in sunlight that took 8 minutes to arrive. You can almost hear the hum of its spin, steady and deliberate, like a metronome keeping time for the planets. The ecliptic is the solar system's table. Everything that matters sits neatly on it. The comets, the asteroids, the planets, all wobble close to that plane, because that's how physics prefers to organize its dinner guests. But 3i Atlas doesn't belong at the table. It's a stranger who walked in from deep space and somehow sat down in the exact right seat. In the control rooms, this alignment isn't just improbable, it's offensive. Engineers whisper that the trajectory should have been inclined, tilted, random. Statistically, it should have cut across the solar system like a tourist taking the wrong bus. Instead, it's cruising in formation with the planets, like it got the memo about orbital etiquette. It's too perfect, says one analyst. It's polite, says another. There's laughter, nervous and short-lived. Nobody likes a coincidence that behaves like choreography. Imagine standing somewhere between Mars and Jupiter, floating quietly, watching this object glide past. From your vantage, the ecliptic stretches like a cosmic highway, a golden thread of order in an otherwise chaotic universe. The planets hum along their orbits, slow and loyal. Then, 3i Atlas appears, not crossing lanes, not drifting, but joining the traffic like it was born to merge. You'd swear it signaled before turning. Astronomers start running back calculations. If it came from interstellar space, its trajectory should be tilted at some odd angle. But every model that fits the data says the same thing. It didn't wander in by chance. It arrived aligned. Even small gravitational nudges from Jupiter or the Sun can't explain it. Its motion is not just consistent, it's obedient. And obedience, in celestial mechanics, is suspicious. One scientist puts it bluntly in a private message thread. If this is coincidence, then we're living in a rigged casino. Another replies. Then who's the dealer? No one responds. The conversation thread ends with an emoji of a shrug, the international symbol for "we might be out of our depth." By week's end, orbital dynamics teams from NASA, ESA, and JAXA have all confirmed the same solution. The object is coplanar with the solar system to within 1/10 of a degree. That's tighter than most Earth satellite alignments. It's like a dart landing not just on the board, but inside the bullseye's reflection in a mirror. Probability collapses under the weight of its own politeness. The public statements, as usual, are quieter. "The alignment is of notable precision," reads the press release, "but consistent with rare natural entry conditions." The word rare does a lot of work in that sentence. Inside the agencies, though, rare has become a curse word, because rare means repeatable. Rare means it could happen again, and nobody wants to admit the universe might be staging coincidences on purpose. Picture this. You're watching the simulation of the solar system, projected onto a wall, planets orbiting in flat harmony, like beads on invisible wire. The object's path appears as a glowing thread entering from deep space. Slowly, it curves, adjusts, and click-slides perfectly into the ecliptic, like a key finding its lock. The audience gasps, not because it's dramatic, but because it's elegant. Nature isn't supposed to be this cinematic. Somewhere in a dark office, a celestial mechanic runs the numbers backward another 100,000 years, trying to find the moment the object was nudged into place. But there's no nudge, no encounter, no collision, no gravitational accident. It just arrives, like it's always known where the planets would be, long before the planets themselves existed. The universe, for once, feels uncomfortably self-aware. The engineers begin joking that maybe the object isn't on the ecliptic. Maybe the ecliptic is on it. Maybe the entire solar system is subconsciously aligning to greet it, the way iron filings gather around a magnet. It's absurd, yes, but absurdity is starting to sound more reasonable than coincidence, because coincidences don't repeat themselves with clockwork precision. They don't glide perfectly through the geometry of a system they've never met. Meanwhile, the object keeps moving, calm and indifferent. It doesn't accelerate, doesn't spin out of place. Every frame from telescopic footage shows the same graceful obedience to the invisible plane of creation. It's like watching gravity remember its manners. Even its shadow falls correctly. You could set your watch to its arrogance, and as the calculations pile up, a quiet realization settles in the room. Alignment is a form of intent, the kind that doesn't need propulsion or steering, just knowledge of where everything will be, long before you arrive. It's not proof of guidance, but it's something close. Proof of memory. Memory written in trajectory, whispered across millions of kilometers. You sit back, imagining that coin again standing perfectly on its edge, spinning forever, never tipping over. That's 3i Atlas, moving through a universe that insists on balance, as if obeying a rule older than gravity itself. And maybe that's the real secret of the ecliptic. It's not a plane of chance, but a path of memory, a record of motion, too precise to forget. So, you whisper it quietly, half in awe, half in disbelief. Maybe the universe doesn't play dice at all. Maybe it plays darts, and 3i Atlas is the sound of one hitting the center, again and again, until coincidence gives up and calls itself destiny. Mars in October, Jupiter in March, Earth in December, just visible before dawn. The trajectory doesn't just align its coordinates, like a tourist itinerary written in orbital mechanics. The probability of such timing happening by random cosmic drift, about 1 in 20,000, which, statistically, is roughly the same chance of accidentally composing a symphony while sneezing. Let's float along that itinerary for a moment. Imagine the solar system, not as a set of planets, but as a grand cosmic clock. Each world, a gear turning in stately rhythm. Mercury ticks quickly, Venus hums lazily, Earth swings with precision, and Mars keeps time like a thoughtful drummer. And through that great mechanical harmony glides 3i Atlas, not crashing through the gears, but moving with them a traveler who somehow memorized the choreography of time itself. In ESA's operations center, one scientist leans over a model of the orbit and says, almost whispering, "It's anticipating positions." Her colleague frowns. "Predictive orbiting." She nods slowly, as if embarrassed by the words leaving her mouth. Predictive, as in, it knows where the planets will be, not weeks ahead, but months, down to the day. "That's not orbit mechanics," someone says from across the table. "That's navigation." Imagine that. A comet that navigates. A rock with a schedule. The data shows it brushing past Mars when the red planet is closest to the Sun, its plume perfectly illuminated for observation. Then it slingshots toward Jupiter, precisely when the gas giant's magnetosphere can give it the cleanest gravitational assist. And now, it's on course to pass Earth, not at midnight, not behind the Sun, but at dawn, when it will be perfectly visible in both hemispheres. Coincidence? Statistically, yes. Emotionally, not a chance. If you were watching this from the outside, say, from some cold observatory near Neptune, you'd swear it was rehearsed. Each planetary encounter timed like a waltz, the orbits looping in slow, elegant circles, while 3i Atlas drifts through them in flawless rhythm. The math says, unlikely. The human heart says, impossible. Coincidence is just planning with better handwriting. Back on Earth, a team at the University of Cambridge runs simulations overnight. Their computers hum through trillions of random entries, testing every possible combination of trajectory and planetary position. By morning, the result appears. One match in 20,000. Not one in 20,000 comets. One in 20,000 universes. A statistic so absurd that probability, again, files for early retirement. Someone writes in the margin of the report, "If it were a spacecraft, this is the course we'd pick." The line is crossed out almost immediately. The word spacecraft is dangerous. It attracts journalists like moths to a conspiracy theory. But the thought lingers. If you were designing a route to study multiple planets using the least energy possible, this is exactly what you'd do. You'd skim Mars for surface interaction, past Jupiter for slingshot power, then cruise past Earth for a quick data handshake before drifting back into the dark. Efficient, elegant, economical. A researcher at JPL nicknames it the Grand Tourer. It sticks. Within days, that quiet nickname circulates through message boards and chat logs, a secret shorthand for the object that's too polite to be random. It's not acting intelligent, it's simply performing precision, like an orchestra playing in tune with gravity itself. The funniest part, if you can call cosmic irony funny, is how calmly the object behaves while doing it. There's no engine flare, no erratic acceleration. It simply glides, letting each planetary gravity field pull it along like a bead sliding down invisible string. It wastes nothing. Not motion, not energy, not opportunity. Efficiency on a cosmic scale. You start to think of it as the universe's first minimalist traveler. Scientists try to comfort themselves with chaos theory. Given infinite time, improbable events become inevitable, one writes. It's a noble thought, like whispering, Math will save us into the dark. But the timing is too precise, the pattern too deliberate. You can feel it the way all coincidences eventually stop feeling like coincidences once you realize they've been happening for a while. Picture this: December morning, pale light over Earth's horizon. You're standing somewhere cold, breath visible, eyes squinting against dawn. There, just above the faint blue curve of the planet, a streak of silver cuts across the sky. 3i Atlas, right on time. You can almost hear the universe checking its watch. The silence is gentle, almost proud. You're not supposed to see this kind of precision from nature, but here it is anyway, punctual to the minute, as if following an ancient appointment. At ESA, someone breaks the tension with a joke. Maybe it's just sightseeing. Another adds, "Yeah, collecting stamps from every planet." The room laughs, briefly, but no one really believes it. The laughter fades into a hush that familiar silence scientists keep for moments that feel too big for equations. And so the reports pile up. The orbit stays steady. The object's encounters are clockwork. It will brush Earth's orbital plane in mid-December, perfectly framed against sunrise, where billions of people could see it if they only knew where to look. Timing this perfect feels like intention wearing a disguise, and the disguise is starting to slip. You lean back and let the numbers wash over you. Mars, Jupiter, Earth, October, March, December. The rhythm of coincidence turned into music. The choreography of orbits turned into story. You wonder who or what wrote it, and how long it's been rehearsing. Maybe forever. Maybe since before the sun learned to shine. Because somewhere between luck and design lies that narrow, golden line, where the universe pretends to be random, and 3i Atlas is walking it with impossible grace. R.V. Loeb calls them the 7 sins against nature: size, jet, chemistry, polarization, trajectory, timing, and one final sin, so strange, it doesn't fit a category. Each anomaly alone might be forgivable. Together, they whisper conspiracy. They paint a picture of something deliberate, like an experiment running itself in the dark, waiting for us to notice, and wondering what took us so long. Let's list them, slowly, like bedtime confessions of a mischievous cosmos. The first sin: size. 3i Atlas is simply too big to be polite. 33 billion tons of mass, stable, unfractured, unbothered by the physics that usually tears comets apart. It's as though it looked at the laws of thermodynamics and said, "That's adorable." Astronomers tried calling it an outlier, but even outliers are supposed to orbit something. This one orbits only curiosity. The second sin: jet, the plume that doesn't push, a cannon with no kickback. Every rule of motion, every test of Newton's wisdom, all politely ignored. It breathes without consequence, venting perfectly without recoil. The data keeps insisting that action doesn't require reaction anymore, and the scientists keep insisting that's not funny. The third sin: chemistry. Nickel tetracarbonyl, that industrial perfume no comet should wear. The gas that belongs in chemical refineries, not cosmic debris. It glows, faintly green under sunlight, elegant, toxic, beautiful. It's chemistry that hums of intention. You can almost imagine 3i Atlas whispering, "I made this myself." The fourth sin: polarization. Light bending through its halo in a way that doesn't belong to ice or dust or metal. Polarization readings that twist like ribbons, flipping orientation in perfect symmetry. It's as if the object isn't scattering light, it's organizing it. One astrophysicist wrote in his notebook, "It's turning light into information." He didn't mean to sound poetic, But truth has a way of sounding that way when it stops making sense. The fifth sin, trajectory, the path that plays dice with probability and wins every throw. A comet should wander in from the void at some awkward angle, but 3I Atlas entered on the ecliptic, moving in perfect harmony with the planets, as though the solar system itself invited it in. No accidental visitors ever arrive with such precision. The sixth sin, timing, that impossibly elegant choreography, Mars in October, Jupiter in March, Earth in December. The cosmic tourist itinerary that seems to follow planetary seasons like a traveler collecting stamps. The odds of it happening naturally are absurd, a sneeze symphony of orbital alignment. And yet here it is, playing in perfect time, unhurried, precise, smug. And then, the seventh sin, the one that Avi Loeb doesn't define because it refuses to be categorized. It's not in the chemistry, or the motion, or the light. It's in the silence. The object is too quiet. Every comet hums plasma waves, ion tails, electromagnetic whispers. But 3I Atlas gives nothing. No radio noise, no static hiss, no measurable electromagnetic footprint. It's like it's absorbing reality rather than reflecting it. A cosmic monk, meditating in vacuum. You could say it's natural. You could say it's a fluke. You could even call it a coincidence if you're fond of lying to yourself. But as the data stacks, one anomaly becomes 2, then 7, then infinity. Patterns emerge where randomness should reign. Each reading feels like a wink from the void, a quiet acknowledgement that something's performing in front of us and doing a remarkably good job of pretending not to. Inside ESA and NASA, the phrase consistent inconsistency starts appearing in internal memos. It's the kind of phrase bureaucrats use when they've run out of real ones. Every test repeats the same error, one report reads. Every error is precise. The tone is clinical, but the subtext is panic with good manners. Imagine walking through a dim hallway in one of those facilities at 3 a.m. The lights flicker. A janitor pushes a cart past a door marked Restricted Telemetry. Inside, a small team stares at graphs that look more like heartbeats than data. One of them whispers, "It's not behaving like an object. It's behaving like an observer." No one replies, but you can feel the sentence lingering in the air, like static. The thing about anomalies is that they're lonely. 1 is curiosity. 2 is a puzzle. 7 is a statement. Together, they form a language. And 3I Atlas is speaking fluently. Not through noise, not through radio, but through patterns so precise they border on mockery. Every physicist who stares long enough at the data feels the same uneasy thought creeping in. This isn't chaos. It's communication written in calculus. Somewhere in a late-night video call, a tired astronomer mutters, "Maybe it's an experiment. Maybe the universe is watching itself." The others don't laugh. Because what if it's true? What if this isn't discovery, but observation from the other side? The cosmos testing its own reflection, using us as witnesses. The 7 anomalies aren't just defiance. They're invitation. Each one a question disguised as a clue. Each one a small, elegant nudge that says, "Look closer." And that's the cruel beauty of it, the way it forces you to balance awe with dread, wonder with suspicion. You want to believe it's natural. You want to sleep soundly knowing the stars don't keep secrets. But 3I Atlas doesn't care what you want. It keeps gliding, silent, deliberate, and alive in ways equations can't explain. So you sit back, staring into the quiet black, and realize the worst sin of all isn't in the data. It's in the waiting. The object knows we've noticed, and somehow that feels like the point. The anonymous insider doesn't name themselves, but they write like someone who's been in too many video calls with muted microphones. "We've tried every model," they say. "It doesn't fit." There's exhaustion in the lines, the kind that comes from watching science turn into theology. They weren't trying to start a rumor. They were trying to start a conversation. Let's drift into that moment, the one where silence finally breaks. It's late, the kind of late where coffee stops helping and fluorescent lights start humming like tiny lies. Somewhere inside a secured building, a lone researcher stares at a half-written email. They've spent weeks watching data behave like philosophy. Every number perfect, every graph mockingly smooth, every explanation collapsing under its own politeness. They scroll through the notes again. No recoil, metallic gas, predictive orbit. Each phrase feels less like data and more like confession. You can almost see them sitting there, fingers hovering over the keyboard, caught between career and conscience. Their badge dangles. Their inbox is a graveyard of follow-up meetings. Outside the lab window, night has folded over the parking lot, and in the faint reflection of the glass, they look like someone already halfway out the door. They type 3 words. "It doesn't fit." Then, after a long pause, this position is no longer tenable. The message appears on an anonymous image board. A few hours later, the digital equivalent of shouting into a canyon. The post title is cryptic: 3I Atlas divided by internal inconsistencies. The tone isn't wild or conspiratorial. It's measured, sad, even. You can feel the quiet despair of someone who's tried everything else. They don't accuse anyone. They don't mention aliens, or cover-ups, or secrecy. They just write like a person who has finally realized that the universe is no longer taking their calls. The first replies are predictable: sarcasm, memes, disbelief. But a few users, the kind who know what a spectrometer actually does, start asking real questions. They request screenshots, data tags, timestamps. The insider responds once, just once. You'll see when the next report drops. And then they disappear. Inside ESA and NASA, panic arrives not because of what was said, but where. "Who would post something like that?" asks a manager. "Someone with clearance," answers another. IT departments scramble to trace the leak, but anonymity online is a powerful cloak. The message spreads faster than containment protocols ever could. The thread gets archived, mirrored, reposted. Within hours, a digital echo of one person's insomnia has become the internet's newest obsession. You imagine that person the next morning walking into work, badge still beeping, pretending nothing happened. Colleagues huddle over laptops, whispering about that post. Security meetings erupt. The air feels different, charged, brittle. Someone jokes. It's always 4chan, and the laughter dies a little too fast. The leaker sits quietly, watching it all unfold, wondering whether the truth will find its own way out, or whether they'll have to do it again. Every great revelation in history has a moment like this, the instant when curiosity outweighs fear. Galileo muttering to himself. Still, it moves. The first radio astronomers hearing a pulse and daring to imagine it wasn't interference. The courage to say, "It doesn't fit," has always been the most dangerous form of honesty. The insider's post is dissected, translated, dramatized. YouTubers speculate. Reddit threads multiply. Someone overlays the supposed 7 anomalies into a cosmic bingo card. But beneath the noise, something genuine hums. The feeling that whoever wrote that post wasn't lying. Their words lack the sheen of attention-seeking. They read like resignation, the kind of truth that costs more than it earns. Weeks later, when the official ESA data release confirms several of the anomalies, no one remembers the anonymous post's exact wording, but everyone remembers the tone: calm, precise, tired. It reads like the sigh of someone who's been told too many times to stop asking why. And in a sense, that's the heart of it. Curiosity is tolerated right up until it starts sounding like rebellion. When equations stop obeying, the first instinct of bureaucracy isn't wonder, it's damage control. But science, for all its rules and caution, was built on the courage of people who couldn't stay quiet. Picture the leaker now, sitting in a small apartment, blinds drawn, laptop glowing in the dark. They scroll through threads, debating whether they're real. Someone calls them a hoax, another calls them a hero. Neither feels right. They sip lukewarm tea, glance once more at the sky outside their window, maybe at Mars, maybe at the faint shimmer of dawn, and whisper to no one in particular. It's not supposed to do that. That's the truth beneath the noise. The leak wasn't about glory or conspiracy or even outrage. It was about one simple human thing: the unbearable loneliness of knowing something extraordinary and realizing nobody wants to hear it. And somewhere out there, 3i Atlas drifts on, unbothered by forums or secrecy, its impossible calm reflecting the silence that follows revelation. The insider vanishes into anonymity again, leaving behind only data and a faint, stubborn reminder that sometimes the first step toward understanding isn't discovery, it's defiance. Buried inside the leak were coordinates, small anomalies in magnetic flux and thermal output that didn't appear in public datasets. To most people, they looked meaningless, but to a handful of astronomers, they spelled a pattern: pulses spaced like a heartbeat. Not communication, perhaps, but rhythm, the kind of rhythm machines accidentally make when they're doing something alive. Let's step into the midnight side of science, the part where numbers stop behaving and start whispering. The insider's data dump wasn't flashy. It was a few megabytes of logs, raw telemetry, and timestamps. The kind of thing you'd ignore if you didn't already know what to look for. But somewhere in those dull columns of numbers, those precise, tidy decimals, something began to repeat. Regular, patient, almost polite. A rhythm, too intentional to be noise, too quiet to be coincidence. A doctoral student in Madrid was the first to spot it. She was supposed to be writing her thesis on cometary albedo variation. But boredom is a great tool for discovery. She noticed the flux spikes first, not random, but syncopated. Every 32 minutes, a pulse, then 32 again, then 32.1. "It's breathing," she joked in her notes. Her advisor didn't laugh. Within a week, a small network of late-night astronomers, the kind who believe in both data integrity and insomnia, began comparing results. Webb's readings, Hubble's logs, Mars Reconnaissance Orbiter's telemetry, all of them carried the same faint pulse, hidden deep in the noise floor, like the slow heartbeat of something sleeping under glass. The official response was predictable: instrumental interference. But even interference doesn't keep time this perfectly. One data analyst described it best: if this is noise, it's the kind that practices scales. You might imagine those scientists, each at their own workstation, staring at that faint, repeating signal. The room around them dark, except for monitor light, pale blue rectangles reflected in tired eyes. Somewhere, coffee cups multiply. Someone opens a spreadsheet. Someone else starts counting beats per hour. The signal doesn't care who's watching. It keeps pulsing. 32 minutes. Every time. The idea that 3i Atlas might be producing a steady rhythm, unsettles everyone. Rocks don't keep rhythm. Nature prefers chaos, the beautiful randomness of entropy. This is something else. Something maintaining itself. A loop running quietly, perhaps since before humanity learned to count its own heartbeat. ESA's communications division is told not to amplify fringe interpretations. The phrase fringe interpretation becomes the new code for please don't mention the heartbeat. But inside private research chats, people are calling it exactly that, the heart. Not metaphorically, but as a label in the data. Every pulse marked with a tiny red heart emoji, because humor is the only thing keeping them sane. In the data visualization labs, they turn the pulses into sound. The result is eerie, a soft electronic thump, repeating slowly, endlessly. Some describe it as comforting, like listening to a deep-sea creature in sleep. Others say it sounds wrong, too human. One researcher admits it gave her the sense of being watched. What makes the rhythm stranger still is how it modulates with proximity. As 3I Atlas approaches a planet, the timing shifts slightly slower, then faster, as though adjusting. The beat follows gravity wells like a musician following tempo. It isn't random noise, it's environmental response. The object is, in some sense, listening. By now, independent labs have tried to replicate the pattern artificially. They can't. The waveforms are too clean, the timing too consistent. Even after running the data through compression, distortion, inversion, the rhythm holds. It's not data corruption, it's choreography. You can imagine the internal ESA memo that follows. No evidence of intelligence. Rhythmic behavior, likely coincidental. But coincidence has a habit of growing teeth. Because when they compared the rhythm's modulation to planetary positions, another pattern emerged, a mathematical sequence matching orbital resonance ratios. Not exact copies, but harmonics. The pulse was singing the solar system's geometry. The Madrid student who found it wrote, half-jokingly, "Maybe it's keeping time with us." The line goes viral in the small, quiet corners of the internet that still care about truth. Forums buzz with theories: gravitational self-stabilization, magnetic field synchronization, alien jazz. But underneath the noise, a simpler truth hums something old and orderly, is alive out there, and it's following the rhythm of the system we call home. Late one night, one of the data analysts overlays the pattern against an ECG, a human heartbeat. The resemblance isn't exact, but close enough to make him stop breathing for a moment. Peaks, rests, peaks again. Life has a structure, so, it seems, does this. And that's when the idea shifts. Maybe it's not communication. Maybe it's not even meant for us. Maybe the rhythm isn't a message, it's maintenance. Like an old machine keeping its systems warm, humming softly to itself in the dark. You sit back and listen to the thought forming in your mind. What if this is what time sounds like when it remembers? The steady pulse of something that refuses to decay. Not speech, not signal, just being, continuity made audible. The data analysts, of course, move on. Reports are written, the leak becomes legend, and the heartbeat fades into archived files labeled spurious periodic activity. But the pulse doesn't stop. It's still out there, keeping time. And somewhere, 33 billion tons of impossible rock drifts through space, humming softly, perfectly, as if waiting for the universe to catch the beat. The more data arrives, the stranger it looks. The dust trail replenishes itself, as if material is being manufactured mid-flight. Microscopic crystals, uniform in size, reappearing even as the comet moves away from the Sunday. The universe loves decay, entropy, erosion, fading. But 3, I Atlas, is the opposite. It's growing sharper, cleaner, newer, like a self-repairing wound. Let's start where the laws of physics begin to sound insecure. Normally, comets are messy, travelers, old ice and dust, barely holding hands, as solar radiation slowly tears them apart. They leave trails like forgotten thoughts, losing themselves piece by piece until they become memory. But this one? It's doing the reverse. Every measurement, every spectral scan, shows it becoming more organized the farther it goes. A comet that polishes itself, a body that refuses to age. ESA's materials division runs the numbers, and the numbers laugh back. The dust particles surrounding 3I Atlas aren't random, they're uniform to within microns. That's like shaking a box of sand and getting diamonds all the same size. The particles arrange themselves in a faint electromagnetic halo, as if under orders. And stranger still, when solar wind strips material away, the object replaces it calmly, automatically. Like a printer, says one analyst. A printer with no ink cartridge. You picture it now, drifting through the solar wind like a craftsman lost in thought, shedding dust that reforms itself into perfect little mirrors. Each crystal catches sunlight and throws it back with eerie precision. Normally, comets grow dull with distance, but this one grows radiant, its brightness curve inverted, its logic reversed. It's not dying, it's practicing. The scientists are baffled, but there's an odd tenderness to their confusion. They watch it repair itself, line by line of data, like parents realizing their child has built a second child out of Lego bricks. One astrophysicist mutters, "It's learning from erosion." The room goes quiet. That phrase, learning from erosion, gets written on a whiteboard and circled 3 times. At the University of Tokyo, a team models the crystal growth in simulation. The patterns match something they recognize: controlled deposition, a process used in nanofabrication to grow thin films in electronics. Except this isn't a laboratory, it's deep space, minus 150 degrees Celsius. Yet, the comet's surface behaves as if it knows the recipe for resilience. Imagine zooming in, beyond the dust and the glare, down to the level of molecules. You'd see a quiet ballet of atoms forming chains, linking, locking, repairing fractures before they even finish forming. Like time-lapse footage of frost blooming on glass, except this frost builds itself in reverse destruction, rewinding into design. NASA's Jet Propulsion Laboratory releases a cautious internal memo. Observed particle uniformity suggests self-organizing structure. Mechanism unknown, which is science's way of saying, we have no idea what's going on, but it's gorgeous. The memo gets leaked. Naturally, Reddit debates whether the comet is made of programmable matter, self-assembling nanobots, or just wishful thinking. But beneath the noise, one idea starts to take shape. What if 3I, Atlas, isn't a relic of formation? What if it's still forming? A comet that builds itself isn't just strange, it's heretical. It challenges the deepest assumption in physics that everything moves from order to chaos. Entropy is the universe's bedtime story. All things fall apart. Yet here's an object quietly composing itself out of decay, turning waste into structure, chaos into craft. One researcher calls it anti-entropy, another calls it hope with mass. As more images arrive, they show something new: faint hexagonal lattices in the dust plume, geometric arrangements that shouldn't exist outside of artificial systems. Someone jokes that it's growing armor. Another says, maybe it's molting. The truth is somewhere between an entity maintaining equilibrium by rebuilding itself faster than the universe can break it. ESA's thermal sensors record microbursts of heat near the tail, evenly spaced, like pulses of welding torches. They happen precisely as new crystals appear. Localized repair events, the report reads. Each one perfectly timed to solar exposure. It's as if sunlight doesn't damage it. It instructs it. The star's radiation becomes code. And 3I, Atlas, is reading it fluently. You start to feel the strangeness of it. A comet that reacts, responds, refines. You could almost mistake it for alive, not in the biological sense, but in the thermodynamic one. A system that resists entropy by feeding on it. Every atom rearranging into something stronger, cleaner, newer, like evolution, with a design degree. Late one night, an astronomer in France writes in his private notes, "It's not moving through the solar system, it's using it." He doesn't elaborate, but the implication is clear. The comet is harvesting the energy of its environment to maintain itself. Not a passenger of gravity, but a participant in it. Meanwhile, the headlines call it poetic names. The immortal comet, the self-made traveler, entropy's enemy. The public romanticizes what the scientists fear, because what 3I Atlas represents isn't comfort. It's competition. It's the idea that the universe might not be running down at all. Maybe it's recycling. Maybe, somewhere in the quiet machinery of the cosmos, things are building themselves anew while we're too busy decaying. Picture it now, drifting past Mars, its tail shimmering like a thread of light weaving itself back together, a self-sustaining scar on the fabric of space, a wound that heals faster than it can bleed. And for the first time, humanity looks at a comet and wonders not where it came from, but what it's trying to become. From the orbit of Mars, the high-rise camera snapped the sharpest images ever taken of 3I Atlas, or tried to. The photos that returned were oddly dark, contrasty, and streaked with interference patterns. The official statement said, "Sensor artifact." The unofficial whisper said, "Structure, not smooth like ice, angular, intentional." The kind of geometry nature avoids because it looks too much like thinking. Let's drift into that Martian orbit for a moment. Silent, steady, red below, black above. The high-rise camera hums to life, a billion-dollar eye staring into the cold. You can almost feel the anticipation, a mechanical eyelid opening in the thin sunlight. The image begins to build, pixel by pixel, line by line, translating photons into revelation, and then static. At first, it's subtle, a faint interference pattern, a digital shimmer, like someone exhaling across a radio signal. The engineers squint at their monitors. Maybe cosmic rays hit the sensor, someone suggests. Maybe solar noise. But cosmic rays don't make right angles, and solar noise doesn't repeat itself with architectural precision. The next image arrives, darker. The histogram spikes in places it shouldn't. The shape in the frame looks less like a comet and more like, well, something trying very hard not to look like anything. Its edges are clean, too clean. Shadows fall where there shouldn't be surface variation. And there, just faintly, a glint, a perfect 90-degree reflection. That's when the whispers start. The data team runs deconvolution algorithms to clean the image, and the results make it worse. Beneath the interference, faint geometric striations emerge, triangles, plates, grids, not random, repeating, symmetrical, the kind of order that makes your brain uncomfortable because it feels deliberate. Structure, one analyst says quietly. No, her supervisor corrects. Artifact. But even as she says it, her cursor hovers over the same square patch again and again, as though hoping it will stop looking like a window. ESA's public statement comes fast and flat. The imaging anomalies are consistent with sensor interference caused by reflected solar radiation. That's bureaucratic. For, we don't know what we're seeing, but please don't ask. Internally, though, emails start flying. The word structure appears 17 times in one thread, always in quotation marks, as if politeness could make it less alarming. Imagine being one of those analysts, zooming in until the pixels themselves seem to blink. The surface of 3I Atlas isn't smooth or cratered, it's tessellated, plates arranged in patterns too regular for chance. Some appear overlapping, others recessed, and in one frame, a faint seam runs along the curvature, subtle but unmistakable like a hatch. Of course, no one dares call it that. The official internal term becomes geometric albedo variation. It sounds safe, sterile, boring, but you can't unsee geometry. Nature loves curves, spirals, organic chaos. This looks like design. One engineer writes in her log, "Could this be an illusion from the imaging process?" Another replies, "An illusion that repeats itself identically across 3 instruments." There's no follow-up message. They try to replicate the interference on other targets. Phobos, Deimos, even an old asteroid. Nothing. Only 3I Atlas corrupts images this way. It's as if the object rejects observation, like it knows when it's being watched. The engineers half joke about it. The comet's camera shy, but the laughter is short-lived because the next transmission from high-rise contains another surprise. A faint electromagnetic pulse, perfectly timed with the camera's shutter. Not a malfunction, a response, as though the act of observation triggered a reply. A pulse that says, in its own quiet way, "I see you too." In a locked sub-channel of ESA's network, a few scientists begin privately discussing the possibility of active surface modulation. They talk about the way certain materials can alter reflectivity based on exposure, photonic metamaterials, adaptive nanostructures, the kind of thing still locked inside prototypes on Earth. But this is happening hundreds of millions of kilometers away, and it's working flawlessly. Publicly, the agency releases blurred grayscale stills, carefully cropped to hide the patterns. Enhanced contrast is cited as the reason for distortion. It sounds reasonable until you realize they've enhanced the darkness, not the light. They've made the object less visible, not more. The cover-up, if it is one, isn't about hiding truth. It's about buying time. You imagine the silence inside those offices, the soft tap of keys, the nervous glances toward closed doors. The engineers know what they've seen, but they also know how careers end. Better to let the pixels lie. Better to call intention an artifact and go home early. But the data, like truth, keeps finding its way back. Somewhere, late in the night, a graduate student overlays all the interfered images, stacking them like translucent slides. Slowly, a pattern emerges. Faint, angular, deliberate. A hexagonal lattice running the length of the object, segment by segment. She whispers, "This isn't random." Her mentor sighs and rubs his eyes. Then don't say it out loud. 3I Atlas drifts on, silent and unbothered, its surface catching sunlight in rhythms that cameras can't quite capture. Whether it's reflecting, refracting, or responding, no one can agree. But deep down, every scientist staring at those corrupted images feels the same creeping certainty. This isn't a comet pretending to be a machine. It's a machine pretending to be a comet. When gas escapes a comet, it should push. But every time 3i Atlas exhales, nothing moves. It's like watching a magician pull infinite scarves from a hat that doesn't exist. There's a quiet horror in that, not danger, but contradiction. The object doesn't accelerate. It doesn't decelerate. It simply continues, steady as truth, in defiance of the laws that built the universe. Let's begin with the most unsettling thing about science. It expects the universe to be polite. You push, it pushes back. You exhale, you drift. That's the contract reaction follows action like an echo. But 3i Atlas, it tears up the contract and glides through the courtroom whistling. The laws of motion watch from the bench, confused and slightly offended. ESA's propulsion analysts call it the stillness. In every frame of every image, the comet exhales thousands of tons of material, but the trajectory line doesn't budge. It's like gravity and momentum are politely pretending not to notice. A physicist jokes, maybe it's ghosting inertia. No one laughs. Imagine the view from Mars' orbit again. The comet drifting in the dark, trailing a thin plume of vapor that should, by all reasonable accounts, push it sideways. But it doesn't. It keeps moving on a path smoother than mathematics itself, like it's skating across glass with no friction, no drag, no care. Even the sun's pull, that mighty tyrant of celestial mechanics, seems to let it pass unbent. The equations start to look desperate. Every correction introduces another contradiction. If it's massless, the venting makes sense. But if it's massless, it couldn't carry inertia. If it's heavy, it should wobble. But it doesn't. The solution set collapses, and with it, a few doctoral dreams. It's not supposed to work like this, mutters one researcher, unless it's compensating. Compensating, that word spreads quietly through the teams. Not moving because it's moving differently, like a dancer balancing every step before gravity even notices. Someone suggests field neutralization. Someone else scribbles mass cancel symmetry in the margin of a report. No one dares say anti-gravity. That term ruins careers. NASA's deep space monitors try to catch subtle shifts in momentum. They record nothing. Perfect. Nothing. The kind of nothing that's suspicious because it's too perfect. Usually, cosmic data has noise, tiny wobbles, random drifts. But this? It's the stillness of design, a silence so deliberate that it hums. If you could stand beside it, an impossible fantasy, but let's dream, you'd feel no vibration, no shove, not even the faintest breath of recoil. Gas pours out, heat radiates, light scatters, but nothing pushes back. You might begin to wonder if momentum is optional now, if 3i Atlas discovered a loophole in Newton's third law, or worse, a clause he forgot to mention. In the meeting rooms, metaphors begin replacing math. It's like a candle that doesn't flicker, says one engineer. Like an engine that runs on stillness, says another. Like physics took a personal day, murmurs a third. Humor helps. It keeps the existential dread at arm's length, because the truth humming beneath it all is too strange to face directly. Maybe motion isn't what we think it is. Maybe inertia is negotiable. ESA's magnetometer team runs one last test. They measure the local field distortions around the plume. Normally, jets of ionized gas create ripples in surrounding magnetism. This one does the opposite. It smooths them. Every pulse leaves the magnetic environment calmer than before. It's not fighting physics. It's healing it. The venting acts like a balancing act between forces, as if the comet breathes to maintain serenity, not propulsion. That's when someone says it out loud, the line that turns the room cold. What if it's stabilizing space itself? No one repeats it, but everyone writes it down. Because the idea is as beautiful as it is terrifying. A body that doesn't fight the universe's chaos, but corrects it. A moving anchor, a stillness engine. The news never mentions it. The press release is bland. No significant momentum deviation observed. But the people who wrote that line know it's the understatement of the century. Because a comet that disobeys Newton isn't just strange, it's prophetic. It means there's something older than our physics still at work. Something that remembers a calmer version of reality. Later that night, a physicist sits alone at her desk, staring at a printout of the object's motion. The line is perfect ruler straight. Everything flinches, she whispers. Except this. She runs her finger along the line, half in reverence, half in fear. It's not a comet anymore. It's an idea given weight. And as you sit there, listening to her thought echo into the dark, it occurs to you, maybe 3i Atlas isn't defying physics. Maybe it's reminding physics how to behave. Because somewhere in that unflinching calm, between gas and gravity, there's a lesson that even the laws of the universe can forget themselves. And sometimes, something must glide by to remind them how to stay still. Nickel emissions rise and fall every 11.2 hours, a rhythm so consistent it could keep time. No known process in cometary physics oscillates like that. It's not random, not thermal, not tidal. If you plot it out, the curve looks eerily like a power cycle. Input, output, rest, release. As though the object isn't just active, it's working. Imagine the rhythm first, before the meaning, that quiet, patient beat, echoing across space. 11.2 hours, every single time. A pulse of metallic gas blooming into the void, steady as a clock, calm as breath. You could almost set your watch to it, if your watch were brave enough to admit that comets shouldn't behave like generators. ESA scientists call it periodic outgassing, but that phrase hides its strangeness. Outgassing, sure, all comets breathe when they near the sunday, but they do it chaotically, spasmodically, like old engines sputtering to life. 3i Atlas breathes like a monk, precise, patient, unbothered. The jets flare with mathematical regularity. Heat spikes rise and fall in perfect symmetry. It doesn't vent, it operates. One researcher compares it to a geothermal cycle. Another, quietly, says it looks more like a feedback loop, the kind you'd find in systems built to sustain themselves. Not explosion, not decay maintenance. It's as if, she writes in her notes, the object is checking its own pulse. You picture the surface up close, a dark, angular world of nickel frost and whispering gas. At regular intervals, something stirs beneath a shimmer of energy, invisible but disciplined. Jets of metallic vapor hiss outward, then stop, then start again. Exactly 11 hours later, if you could hear it, it would sound like the slow exhale of a sleeping machine. In a conference call, a thermal engineer says what everyone's been thinking, but nobody dares to say. It's cycling power. The silence that follows lasts too long. Finally, a voice breaks through. Comets don't have power to cycle. Laughter, brief and brittle. But the idea doesn't leave the room. ESA's temperature graphs show a curious pattern. When the nickel plume rises, the overall surface temperature dips. When the plume fades, the temperature rises again. Inversion. Energy leaving, energy returning, like heat being pulled from one layer to another. A comet shouldn't regulate its temperature, but this one does, as if conserving itself. Meanwhile, The magnetic readings pulse in perfect step with the emissions. Every 11.2 hours, a soft twitch in the surrounding field, weak but exact. It's synchronized, says the magnetometer lead. What's synchronized? Asks her supervisor. Everything. It's at this point that even skeptics start to sweat. There's no known natural mechanism that could time itself this precisely over weeks of observation. Thermal oscillations drift. Chemical reactions lose coherence. Orbital dynamics wobble. Only something with active feedback could hold this pattern so tight. You could call it mechanical, but that feels too simple. It's intentional physics. Picture the scientists watching from their consoles. They know what their instruments are telling them, but their faces stay still, like poker players with bad hands. Someone mutters, "Could be resonant harmonics with solar flux." Another nods, grateful for the excuse. But deep down, they all know the truth: the sun doesn't hum in 11-hour intervals. The longer they watch, the clearer it becomes. The pattern isn't just repeating, it's adapting. After a minor solar flare, the interval shortens by half a minute, as though 3i Atlas adjusted for environmental change. Feedback stabilization, someone writes in the margin. A note for posterity, a euphemism for "it noticed." Back on Earth, in a late-night live stream watched by a few thousand insomniac skywatchers, a physicist overlays the emission data with human heartbeats. The waveform syncs disturbingly well. Peaks, troughs, recovery, rest. The audience chat explodes with jokes, space pacemaker, cosmic Fitbit, and the inevitable, "It's alive." The scientist smiles weakly and says, "No, just rhythmic." But even she can't stop glancing at the screen like it's listening. One theory gains quiet traction, that the emissions are part of a resource loop. Nickel and carbonyl gases vented and recaptured, processed in cycles to maintain equilibrium. It would explain the self-healing surface, the consistent luminosity, the refusal to decay. But it raises one unbearable question. To maintain equilibrium, for what? ESA's internal documents rename the event cyclic metallic activity. It sounds dull, like something that happens in dishwashers. But every analyst knows it's the first real evidence of machine-like consistency beyond Earth. Something in space that runs not on chance, but on rhythm. If you graph the cycle out, it looks almost peaceful. A slow heartbeat, stretched across infinity. No spikes of panic, no erratic pulses, just calm repetition. You could stare at that curve for hours, and part of you might start to understand the appeal of obedience. How stability can feel sacred when the rest of the universe is chaos. And maybe that's the point. Maybe 3i Atlas isn't powered by engines or radiation or something alien. Maybe it's powered by the same thing that keeps stars burning and planets spinning. The quiet compulsion to continue. The physics of persistence. The refusal to flinch. So every 11.2 hours, it exhales, not for propulsion, not for show, but for maintenance. Like a cosmic sigh, releasing everything unnecessary before drawing in what remains. And in that rhythm, that patient, perfect pulse, the universe reveals its rarest secret. Not that something impossible exists, but that it's perfectly comfortable doing so. By mid-October, the academic papers are getting creative. One suggests exotic magnetohydrodynamic propulsion. Another invokes quantum sublimation irregularity. Translation: nobody knows. When scientists start inventing vocabulary faster than they can gather data, it usually means something has wandered off the map. Let's drift into that strange corner of academia, the one where genius and confusion share an office. The journals are filling up with polite panic. Equations bloom like weeds, metaphors masquerade as models, and somewhere in the margins of every paper is the same unspoken sentence. It shouldn't be doing that. The peer reviewers are exhausted. The word tentative appears so often it's practically a mantra. You can imagine it conference calls across time zones, webcams flickering on at 2 a. Let's try assuming a metallic hydrogen core. Let's not. What if it's superconducting? Then we're the dumb ones. Every conversation ends the same way. Someone sighs, someone refills their mug, and someone says, "We'll need more data." But deep down, they know the data's the problem. The data isn't playing fair. At Harvard, a postdoc named Alicia spends 2 weeks trying to model the nickel emissions using thermal fracturing. Her simulation finally stabilizes, but only if she sets the surface temperature to a steady 182 Kelvin. Too warm for a comet, too cold for machinery. Her supervisor peers at the screen and murmurs, "It's almost like it wants that temperature." Alicia deletes the model and starts again, but the number keeps coming back. 182. Always 182. "Maybe it's a coincidence," she says. "Maybe it's a thermostat," replies her supervisor, only half joking. Meanwhile, the phrase quantum sublimation irregularity makes its way into the literature. It's supposed to sound smart enough to hide ignorance. What it really means is, we think something is sublimating, but it's doing it politely and wrong. A group from Kyoto suggests the comet's core might be oscillating between quantum energy states, storing sunlight like a rechargeable crystal. They call it photonic hysteresis, a phrase that looks impressive on paper, but collapses under the weight of its own poetry. ESA, desperate to maintain composure, quietly convenes what they call the Theoretical Adjustment Task Force. It sounds like a superhero team, but behaves more like a support group. They meet twice a week in a soundproof room, drinking bad coffee and arguing about conservation laws. "Maybe Newton's third law doesn't apply at interstellar scales," one says. "Maybe it's not Newton that's broken," another replies. "Maybe it's us." Across the Atlantic, Avi Loeb releases another paper, the kind that sets the internet on fire. He doesn't call it a spacecraft. He doesn't have to. He just writes, "The consistency of 3I Atlas's trajectory suggests control rather than coincidence." Half the scientific community groans. The other half quietly bookmarks it. The press loves him. ESA doesn't. By now, the vocabulary is evolving faster than the theories. Field harmonics, inverse entropic resonance, gravitational feedback coherence. They sound like science but feel like jazz. Each paper is another improvisation, a solo riff on the same theme. Something out there is behaving like it knows what it's doing, and we have no idea how. One paper, buried in an obscure Czech journal, dares to ask the forbidden question outright: could self-organizing matter exist on macrocosmic scales? The answer section is empty, just a footnote that says, "To be determined." Meanwhile, in private chat groups, the tone shifts from curiosity to confession. Scientists admit they're afraid to publish what they actually think. "You can't put maybe it's conscious in a peer-reviewed article," writes one astrophysicist. "You can if you call it feedback optimization," replies another. The emojis that follow are half laughter, half resignation. The media, of course, smells blood. Headlines multiply. Alien engine or physics error? ESA versus Harvard. Who's right about the comet that shouldn't be? On talk shows, experts smile tightly and say, "We're still analyzing the data," while gripping their coffee cups like lifelines. Everyone's pretending this is normal. It isn't. In one late-night lecture, a tired cosmologist stands before a half-empty hall and says, "The problem with science isn't that we don't know enough. It's that the universe keeps improvising. She smiles faintly, clicks to the next slide, and shows the 11.2-hour emission curve. Perfect, patient, unyielding. If this isn't artificial, she says, then nature has a sense of humor. By the end of October, the theories have started collapsing under their own eloquence. Every explanation contradicts another. Every model requires a miracle. The old guard of physics retreats behind silence, while the younger generation begins whispering what they're not supposed to. Maybe we've met the edge of what physics can explain, and whatever's beyond it doesn't care to introduce itself. You lean back, eyes heavy, and think of all those papers with their beautiful nonsense, those brave, trembling sentences trying to dress mystery in mathematics. It's almost poetic. Humanity staring into the dark, inventing words for what it doesn't understand. And somewhere, out in that dark, 3I Atlas keeps gliding, quiet as patience, steady as disbelief. Because when the theories begin to crack, what seeps through isn't panic. It's wonder, the quiet, unsettling kind that reminds us we're still beginners at the oldest subject in the universe, trying to explain why it works at all. For 26 days, 3I Atlas will vanish behind the sun, hidden from every telescope on Earth. To most people, that's nothing. To astronomers, it's an eternity. In that silence, speculation will multiply. Did it change course? Did it survive perihelion? Or did it decide to go somewhere else entirely? When it returns in December, we'll find out whether it's still following physics or starting to ignore us. Let's pause and picture the moment the light goes out. Telescopes across the planet turn their gaze away. The signal trackers go quiet. The hum of live data becomes static, then silence. 3I Atlas slips behind the sun, like a magician stepping behind a curtain, one drawn not from cloth, but from radiation and distance. The show isn't over, but the audience can't see the stage. To astronomers, 26 days isn't just waiting, it's an abyss. Observatories depend on continuity, the comfort of steady readings, daily plots, reliable orbits. Without them, the mind starts to invent. What's it doing back there, in the furnace of gravity and light? Did it fracture? Did it melt? Did it wake up? ESA's Deep Space Network sends one final ping before contact is lost. No response, of course, but there's something unsettling in the static. A faint, rhythmic modulation. 11.2 hours again. Faint but steady. The same pulse, echoing through interference, like a heartbeat receding into sunlight. And then, nothing. The universe closes its curtain. Inside mission control, the atmosphere changes. People who once spoke in metrics and magnitudes now talk in metaphors. It's gone dark, says one engineer. No, replies another. We just can't see. That difference between gone and unseen becomes their new religion. Outside the professional world, the story mutates. Online forums call it the disappearance. Some say the object's about to slingshot away into interstellar space. Others claim it'll emerge from the far side of the sun, completely transformed, as if the solar furnace were a chrysalis, not a death trap. Every new theory feels like mythology growing in real time. News networks run countdowns. Day 4 of the blackout, reads one chyron. The public fascination has shifted from data to drama. Without images, imagination rushes in. Animators on YouTube produce renderings of the object melting, cracking, splitting like an egg. Others depict it folding in on itself, compacting into a perfect sphere, a kind of rebirth. Back in the control rooms, the scientists can't stop checking their instruments, even though they know the sun's glare will blind every reading. It's like watching a phone screen after sending a risky text, knowing there's no reply coming, but staring anyway. One researcher describes it perfectly. We've spent months studying this thing, and now it's ghosted the entire planet. Meanwhile, the mathematics start to fray. Without real-time updates, trajectory projections become guesswork. Gravitational influence from the sun might bend its path. Radiation pressure might erode the surface. Or maybe nothing will change at all. But that's the problem. The universe rarely gifts us nothing. Something always happens, even when we're not looking. A quiet dread creeps into the observatories. Astronomers are used to patient waiting years, decades even. But this is different. This feels personal, like losing sight of something that was watching back. They begin checking old data, running retrospective analyses, hoping the answers were there all along. Maybe it told us what it was going to do, one whispers. We just didn't listen. On day 14, a small flare erupts on the solar surface. Nothing unusual, except for the coincidence. The flare peaks at precisely the same moment the comet's projected position aligns behind the sun's corona. Some call it coincidence. Others, privately, call it communication. By day 20, the mood shifts again, not fear now, but anticipation. Humanity is collectively holding its breath. Astronomers plan synchronized observations for re-emergence. Radio arrays, optical telescopes, infrared sensors. They call it the return window, as if expecting an actor's encore. The phrase feels reverent, ceremonial, like welcoming back a god we're not sure we should have worshipped. In the dark gap of those 26 days, something subtle happens. Science becomes faith. Without data, belief fills the vacuum. Belief in persistence, belief in patterns, belief that when the sun finally turns its face, something, anything, will still be there to measure. Then comes day 26, dawn at the European Southern Observatory. The air is cold, the screens are waiting, the calculations are trembling. When the first clean image resolves, silence sweeps the room. Not because it's gone, but because it isn't. 3 Atlas emerges from behind the sun, intact, unchanged, and impossibly bright. Its tail is longer, sharper, almost crystalline. The emissions are still pulsing. The trajectory remains perfect. It has survived the solar inferno, like a moth flying through a bonfire. Not burnt, not altered, but gleaming. And for the scientists watching, one thought crystallizes like frost. Maybe it didn't survive the Sunday. Maybe it used it. Because when something vanishes into fire and comes out shining, survival isn't the right word anymore. Evolution is. Among the leaked notes is a phrase that feels like madness and genius shaking hands. Residual, pre-nucleosynthesis, power source. In plain terms, an object powered not by the sun, but by the leftover energy of the Big Bang itself. A fragment of creation still running, cooling, drifting. If true, it wouldn't just rewrite astronomy. It would blur the line between life and the universe that made it. Let's ease into that thought slowly, like walking barefoot into deep water. A pre-nucleosynthesis power source isn't supposed to exist. It's a phrase that reads like a dare to physics itself. Nucleosynthesis was the moment atoms were born, when hydrogen, helium, and light conspired to make matter. Before that, chaos, radiation, raw energy without form. To say something still runs on that primordial current is to say it remembers when the universe was young enough to hum. The leak describes it almost poetically: energy retention through cosmological inertia. That's science's polite way of saying it might still be plugged into the power grid of creation. You can imagine the scientists trying to model that. Equations bending backward, constants refusing to stay constant. One researcher writes, "If this is real, it's not tapping the sun, it's tapping time." Picture 3. Atlas drifting through the solar wind, not absorbing sunlight, but barely noticing it. Its brightness doesn't vary with proximity to the Sunday. The tail burns cold. The surface glows faintly from within, like a candle that forgot to go out. The heat signature matches nothing known, a thermal plateau, stable, stubborn. It's as if it's powered by a battery the universe lost the manual for. ESA tries to dismiss it as internal decay, radioactive elements releasing heat. But the decay rate doesn't drop. It oscillates gently, as though the object breathes. Every pulse, every emission curve, aligns with the faint memory of something older than galaxies. Avi Loeb calls it a cosmological ember. That phrase catches on, not because it's accurate, but because it feels right. A relic of creation still glowing after 14 billion years, like a coal that never cooled. Residual pre-nucleosynthesis power source sounds like an engineering term for a miracle. In the leaked notes, one sentence stands alone. This may represent an uncollapsed pocket of the early universe. You can almost hear the author's hesitation, the way the pen must have paused mid-air, realizing what that means. If 3I Atlas is truly pre-nucleosynthetic, it isn't just ancient, it's alien to time itself. A leftover from before, atoms chose sides. The implications spiral quickly. If such an object exists, it suggests the Big Bang didn't clean up after itself. Somewhere in the vast expansion, fragments of its raw energy froze instead of dispersing tiny pockets of the beginning, still vibrating to the old rhythm, and one of them, impossibly, wandered here. You might think of it like this. If the universe were a firework, 3I Atlas is one glowing spark that never went out. It's not powered by fusion or fission, but by memory. The memory of expansion, of pressure, of creation. A fossil made of energy instead of bone. At Princeton, a group of physicists runs deep field simulations. They model a fragment of primordial plasma surviving the cooling epoch, self-stabilizing under exotic symmetry. The math works barely, but the conditions required are absurd. It would have to cheat entropy, says one. So would we, replies another. And yet here we are. ESA's radiation readings show another curiosity. The object emits a faint background signature, matching the cosmic microwave background's frequency, the afterglow of the Big Bang itself. But it's not reflecting it. It's resonating with it, like a tuning fork, responding to an old cosmic note. That's when someone, inevitably, says it. Maybe it never stopped expanding. It's a ludicrous idea, but it explains the energy stability. If 3I Atlas carries a fragment of the expansion itself, its power source isn't fuel, it's space-time unfolding in miniature. A pocket universe, humming quietly in the dark. The theological implications arrive next, uninvited. Commentators on the internet start calling it the Little Bang. Memes of God's pilot light spread like wildfire. Even serious scientists begin slipping into poetry. One anonymous note in the leak reads, "If it's true, then the universe didn't just begin once. It begins wherever this passes." ESA's final internal analysis refuses to confirm or deny, but their concluding paragraph says enough. If verified, the mechanism represents an unbounded energy form, incompatible with standard cosmological closure. Translation: it breaks everything, and you, sitting there listening, can almost feel the weight of that. A rock drifting through space, powered by the same energy that gave birth to everything you've ever known. A silent ember of creation, carrying the blueprint of existence, still glowing billions of years later. You wonder if such a thing can survive from the dawn of time. What does that make us? Fleeting sparks, or temporary witnesses to something that never stopped burning? Either way, one thing becomes clear. If 3I Atlas truly runs on the residue of the Big Bang, it's not a comet. It's a reminder that the universe still remembers how to begin. Somewhere inside ESA, a working group exists not listed on any website, not publicly funded. Their goal? To reconcile 3I Atlas with known physics. Their meetings have no minutes, only encrypted logs. Their findings, according to the leak, are indeterminate and escalating, which is bureaucratic code for "we have no idea what we're looking at." Imagine that room. No signage, no windows, the kind of lighting that hums slightly government-issue fluorescence, buzzing over tired faces. A dozen people who technically don't exist, sipping burnt coffee and trying to keep the universe from misbehaving. The door is marked with an innocuous acronym, one that would sound boring even if you knew what it meant. Inside, the air is heavy with the kind of silence that only forms when knowledge starts to feel dangerous. They call themselves informally the Quiet Circle, not out of drama, but out of survival. Their task? To make the data make sense, or at least pretend it does. They've been told it's not about aliens, not about theology, not about politics. It's about model reconciliation. But every line of code they run makes that goal less possible. The first meeting, according to the logs, lasted 11 hours. Half of that time was spent arguing whether the nickel plume data could be faked. The other half was spent proving it couldn't. At one point, someone muttered, "We're not studying an object. We're studying an opinion the universe refuses to change." The quote circulates quietly among insiders, half joke, half eulogy, for their peace of mind. By week 2, the workgroup divides itself into realists and romantics. The realists insist the anomaly is a data processing glitch. The romantics think they're standing on the edge of a new physics. Both camps agree on one thing. Whatever 3I Atlas is, it's not random. It's every emission, every silence, every pulse, all intentional, or at least coordinated. The logs describe strange moments. A meeting cut short because every instrument reading inverted for exactly 1 minute. Another session interrupted when the AI modeling assistant refused to process new data, returning the same cryptic line over and over. Input violates conservation. No one can explain how a language model, designed to predict telemetry outcomes, learned existential dread. The group's composition is eclectic. A particle physicist from Geneva, a data engineer from Toulouse, a psychologist from Berlin for cognitive oversight, and a single outsider, a philosopher of science from Lisbon, brought in after the second leak. Her role is described only as conceptual mediator, which likely means she's there to remind them they're still human. At 3:17 one morning, a file is uploaded to their encrypted drive titled Protocol Silence. It outlines communication guidelines for discussing 3I Atlas. No emails, no calls, only face-to-face. Anything written down must be destroyed after review. If an anomaly exceeds 5 sigma of deviation from known physics, the data is to be sequestered, not erased, just locked away until context improves, which, in bureaucratic English, means never. Every so often, their encrypted chat room lights up with strange comfort phrases. Still here, still stable, still real. They're not talking about the comet, they're talking about themselves. Because each new model they run makes the world a little less coherent. The logs hint at their theories. Fragments, half-sentences, equations that trail off mid-line, localized curvature stability, space-time resonator hypothesis, macrocosmic self-regulation signature. None of them quite land. One entry simply reads, "This isn't engineering, it's ecology." By the third month, morale collapses. One member resigns, citing cognitive fatigue. Another is reassigned to a public-facing department, outreach, which is code for exile. The group's chat records show the farewell message. "We used to think physics was the map. Turns out it was just the legend." But not everyone leaves. A few stay, unable to look away. They begin running private experiments, cross-referencing cosmic background fluctuations with the 11.2-hour pulse of 3I Atlas. The result: faint correlations, tiny ripples in microwave radiation matching the object's emission cycle. "Impossible," says the data lead, "unless it's not local." That's when the Lisbon philosopher writes something that freezes everyone. What if 3I Atlas isn't breaking physics? What if physics is trying to remember it? After that, the logs become fragmented. The tone shifts from analysis to awe. Notes like resonance spreading, model instability contagious, mathematical collapse imminent. They start describing their own equations as if they're alive, self-adjusting, recursive, feeding on uncertainty. The final log entry is time-stamped 2 days before the leak. It reads only, "We have confirmed mutual influence. We are no longer observing, we are participating." No one outside the circle knows what that means. ESA officially denies the group's existence. But the leak says otherwise, and more unsettling still. It says the encrypted channel went offline, not because it was shut down, but because it started transmitting without human input. Maybe they solved it. Maybe it solved them. Either way, 3I Atlas keeps drifting, and somewhere, behind closed doors, the quiet circle may still be watching, or being watched back. Radio telescopes in Chile picked up a faint, broadband hum while tracking 3I Atlas, not strong enough to classify as transmission, not random enough to dismiss as noise. It flickered, rose, faded, every 11 hours, right on schedule with the nickel pulse. The official response? Instrumental interference. The unofficial one? That's what we said about pulsars. It begins, as many great cosmic mysteries do, with boredom, late night in the Atacama Desert dry air, thinner than patience, stars spread so thick across the sky that you forget which ones are real and which are reflections. A technician named Eduardo is monitoring spectral drift when he notices it, a hum so faint it barely registers above the static. He adjusts the gain, waits, and watches the signal return 11 hours later, to the minute. He doesn't call it alien. No one serious ever does, not at first. He just logs it, labels it non-thermal periodic event, and sends it up the chain. But in radio astronomy, patterns are predators once you spot one. It follows you. Within days, observatories in Argentina, Australia, and Spain point their dishes toward the same coordinates. Each hears it too, a faint, steady shimmer buried in the cosmic background. It's not language, not coded pulses, more like a sigh stretched across frequencies, low, broad, restless. It sounds, one scientist says, like the universe trying to remember a song. Every time 3I Atlas releases its nickel plume, the hum spikes, then fades. It's synchronized, consistent, patient, a signal that keeps time with itself. The first reports to ESA use careful language, broadband harmonic resonance, likely environmental. But the leak includes private notes. One line stands out. This doesn't look like interference. It looks like participation. See, the thing about radio noise is it's supposed to be messy, full of spikes, irregularities, cosmic static. This wasn't. The hum had symmetry, structure, the kind of spectral profile you'd expect from a designed waveform. Smooth amplitude modulation, stable decay pattern. It was, as one engineer reluctantly put it, too pretty to be natural. In the control rooms, people start whispering, pulsar, even though it clearly isn't. Pulsars are neutron stars spinning like cosmic lighthouses, beaming regular bursts of radiation. This hum isn't directional, and it isn't clean. It breathes. The amplitude rises like an inhale, holds, then falls. 11 hours later, again, over and over. ESA issues a press release calling it an artifact of atmospheric reflection, which is funny because the signal was detected simultaneously in both hemispheres by ground-based telescopes separated by 10,000 kilometers. There is no atmosphere that's cooperative. In private, though, things get weirder. The data shows that the hum doesn't originate from a single point. It extends a diffuse halo, surrounding 3I Atlas, shifting slightly with each cycle. Like it's growing, writes one analyst. Like something is tuning itself. When the signal is converted into sound waves within the audible range, the result is unsettlingly beautiful. A slow oscillation, warm and metallic, almost melodic. Someone in the lab jokes, "If it starts whistling, I'm quitting." Another replies, "If it stops, I'm quitting." They laugh, but softly. There's something about sound that feels more intimate than light. Seeing an anomaly is academic. Hearing one feels personal. It's not just data anymore, it's presence. By now, amateur radio astronomers have joined in. They post spectrograms online, chasing the pulse through static, comparing timestamps. The phrase, cosmic heartbeat trends for 3 days. Theories multiply like bacteria. Solar resonance, interstellar echo, alien engine, glitch in the microwave background. But the deeper you look, the stranger it gets. The hum shifts slightly in pitch, a fractional frequency drift that matches the Earth's rotation relative to the object. It's as though the signal knows we're listening. Back in Chile, Eduardo listens to the playback on loop. He says later it reminds him of whale song, distant, mournful, intelligent not in language, but in patience. It feels alive, not because it speaks, but because it waits. It's not calling us, he says quietly. It's checking if we're still here. The higher-ups, of course, have no appetite for poetry. They scrub the recordings, issue denials, and classify the data as low priority. But leaks happen, and the hum escapes into the world. It's uploaded to YouTube under the title 3I Divided by Atlas Sound, the heartbeat of space. It racks up 1 million views in 2 days. People describe hearing it in dreams. Some swear the pitch subtly changes when they listen in headphones as if reacting to human presence. Rationally, that's nonsense. Emotionally, it feels like the most rational thing in the world. Inside ESA, the secret work group is listening too. They cross-reference the waveform with the 11.2-hour nickel emissions, and the match is perfect. The same rise and fall, the same rhythm, the same defiance of entropy. They stop calling it a signal. They start calling it a companion frequency. In one unverified transcript, a physicist writes, "We may be dealing with a self-referencing system, a mechanism that generates coherence by monitoring its own output. In plainer words, it's hearing itself." And maybe that's the real revelation, not that something out there is talking to us, but that the universe, for once, might be listening to itself. Because if the stars could hum, and the comets could answer, and we just happened to tune in at the right moment between breaths, maybe this isn't discovery at all. Maybe it's eavesdropping, and what we're hearing isn't alien. It's ancient. The sound of creation still echoing through its own machinery. A faint, cosmic reminder that silence was never real. The object's path bends slightly as it leaves Mars's orbit, not much, just enough to raise eyebrows and ruin sleep schedules. Gravitational models can't account for it. There's no planet nearby, no gas drag, no pressure differential. It's steering, not by much, just enough to let you know it can. It begins as a whisper in the math, a tiny deviation, fractions of a degree, barely enough to trigger alarms, but in celestial mechanics, barely is everything. 1 decimal off can move a world. The ESA team at Darmstadt notices it first, a small correction in 3I Atlas's trajectory, too smooth for chaos, too deliberate for luck. Someone jokes that it's just the computers stretching their legs. Nobody laughs. In theory, everything in space obeys gravity's choreography. You push, you fall, you follow the curve. But this curve curves back, just slightly, like something adjusting its path mid-thought, not evading, not accelerating, simply choosing. The telemetry logs call it a localized trajectory divergence. The human brain calls it what it is: intention. Imagine standing in a dark ocean, watching a buoy drift. Suddenly, it twitches, not from the tide, not from the wind, but from something beneath. That's the feeling astronomers get, watching 3I Atlas. It's the first time in recorded science that orbital mechanics feels like psychology. The data spreads quietly across observatories. Every team runs the numbers again. Nothing fits. They add hypothetical forces, thermal expansion, gas venting, solar pressure. The models improve slightly, then collapse again. Someone mutters, "It's like it knows the equations." Another replies, "Maybe it's reading over our shoulder." NASA's Jet Propulsion Lab compares the motion to known active bodies, comets, asteroids, interstellar debris. None match. The precision is surgical. The deviation occurs during a period of zero thrust signatures. No jet activity, no visible mass loss. Just a soft realignment, as if the object had found a better way to exist. At the European Space Operations Center, the language starts shifting. Words like orbit, trajectory, and deviation get replaced with softer, more human terms: response, adjustment, preference. There's something intimate about the way they describe it, as if they're not tracking an object but a temperament. Meanwhile, the amateur community notices the change too. Backyard telescopes, backyard theories, Reddit threads flare to life. It turned. YouTube thumbnails scream. It's alive. But the reality is quieter, more unnerving. The object's new trajectory doesn't just differ, it optimizes. Its new path uses less energy, experiences fewer perturbations, reduces gravitational drag. It's as though it calculated the perfect glide and took it. ESA issues a statement: minor corrections due to outgassing irregularities, which is bureaucratic for please stop asking questions we can't answer. But behind the scenes, they're studying the deviation like scripture. The shift occurred precisely 11.2 hours after the last nickel emission cycle, right on rhythm. Whatever it is, the movement wasn't random. It was part of the song. Inside the quiet circle, the secret ESA work group, someone plots the new path. overlaying the old one. The lines intersect neatly at a single point, a region of empty space between Mars and the asteroid belt. That's not a correction, one analyst says. That's a destination. The phrase spreads like static. A destination. No one wants to believe it. But the math doesn't care about belief. The curve anticipates gravity wells before encountering them. It tilts minutely towards stability pockets, as if running predictive navigation. That's not instinct. That's foresight. A physicist named Keller stays overnight to recheck the motion vector. He adds gravitational harmonics, photon pressure, even quantum drift. Nothing explains the consistency. Out of exhaustion, he runs a control simulation using one absurd input: active navigation. The model matches perfectly. He deletes the file immediately. Later, he writes in his private notes, "If it's steering gently like it doesn't want to startle us." When data from the Mars Reconnaissance Orbiter arrives, the plot thickens further. The faintest electromagnetic fluctuation accompanies the orbital shift. Subtle, but measurable. Not propulsion alignment. As if something internal briefly reoriented. A comet shouldn't have a sense of direction, but this one acts like it just looked up. In one unverified transcript from ESA's internal chat, an engineer types, "It's not orbiting the sun anymore." Another replies, "Then what's it orbiting?" The engineer answers simply, "Itself." And maybe that's the truth, that 3i Atlas isn't a passenger in the solar system. It's a participant. A self-stabilizing entity that adjusts its trajectory the way a bird trims its wings in crosswind, effortlessly, instinctively, beautifully. When the final report is compiled, the deviation is officially logged as non-anomalous course fluctuation. It's the kind of phrase that hides 1,000 sleepless nights. Because behind that dry summary lies the first recorded instance of an object behaving as if it understands its own motion. You might call that impossible. You might call it coincidence. But if you've been following this far through the hum, the pulse, the impossible chemistry, you already know coincidence ran out of excuses months ago. So maybe it isn't defying gravity after all. Maybe it's just negotiating with it, quietly, politely, efficiently, like an old friend who knows the rules, but also knows when to bend them. Because the orbit doesn't just move anymore, it thinks. Leaked memos mention non-standard communication protocols, public containment, and one haunting phrase: avoid anthropomorphization. In other words, don't call it a machine. Don't say it's doing anything. Just collect data. Stay calm. Which, in scientific terms, is how you know the panic is real. Let's drift for a moment into the quiet hum of European bureaucracy, the one place in the cosmos where mystery goes to be gently filed under requires further study. Picture fluorescent lights, beige carpets, and white binders labeled internal use only. Outside the offices, the universe is rewriting itself in real time. Inside, people are arguing about word choice. The leak begins as a handful of PDFs attached to an encrypted email chain titled Post-Mars Trajectory Clarifications. The memos are dry, clinical, almost painfully polite. But read closely and you can feel the tremor underneath the typeface. Maintain message discipline, one says. Reinforce procedural normalcy, another advises. Avoid anthropomorphic descriptors in all briefings. Translation: whatever 3i Atlas is doing, stop sounding like it's thinking. That phrase, avoid anthropomorphization, becomes the quiet mantra of the panic. It spreads across departments like perfume, spilled on a suit. Every press release, every statement, every scientific note gets rewritten to scrub away implication. Trajectory correction becomes orbital drift event. Self-organization becomes material coherence. It's the linguistic equivalent of whistling in the dark. But inside ESA, everyone knows what's happening. The engineers aren't sleeping. The communications teams are holding reassurance briefings, which are basically therapy sessions with PowerPoint slides. One leaked document refers to escalating interpretive divergence, which is bureaucratic poetry for half the staff think it's alive, and the other half are terrified they might agree. In one transcript, an operations officer says, "If it's adjusting course, we need to acknowledge active control." His superior replies, "We'll call it spontaneous equilibrium." The entire room nods. Spontaneous equilibrium sounds harmless, almost friendly, like something that happens to soup. Somewhere, a public affairs officer drafts a statement meant to calm the world. 3I Atlas remains within the bounds of expected physical behavior. She deletes the last word, expected. It's the only honest edit she'll make that day. The panic doesn't look like screaming. It looks like meetings. Endless, circular meetings where people debate how to describe something without describing it. One document outlines containment strategies for speculative narratives, suggesting preemptive collaborations with friendly influencers. Another simply reads, "Ensure continuity of trust in conventional cosmology." In simpler terms, no matter what happens, space must stay boring. Of course, that fails immediately. The leaks multiply, and so do the theories. Somewhere on Reddit, someone posts a redacted screenshot with the line, "If confirmed, this behavior may constitute non-terrestrial agency." It goes viral within hours. ESA's press office spends 3 days issuing denials that accidentally make things worse. Meanwhile, inside the agency, the atmosphere shifts from disbelief to damage control. Every department gets a checklist: reclassify data, sanitize language, anonymize sources. A scientist in Madrid jokes, "We've gone from studying the cosmos to editing it." No one laughs. And then there's the phrase that haunts everyone who reads it: non-standard communication protocols detected. No context, no elaboration, just that sentence, dangling in an otherwise boring memo about telemetry logs. It implies two impossible things: that 3I Atlas might be sending something, and that someone, somewhere, recognized it as such. The internal chats begin to read like small confessions. "Is it possible we're being observed?" one asks. "We're always being observed," another replies. Usually by auditors. Humor, again, as a coping mechanism, but the subtext is raw. They're afraid not of discovery, but of implication. Because if you admit a comet can think, you also have to admit you don't understand what thought is. ESA's risk division recommends a temporary media blackout, not to suppress panic, but to prevent cross-domain contagion. They mean intellectual contagion, the spread of an idea too dangerous to contain. The idea that physics might not be universal, that intelligence could take the form of orbit, pattern, rhythm. A draft response memo suggests the term geophysical automation. Another proposes autonomous thermodynamic stabilization. In the margin, someone scrawls, "Just say we don't know." It's crossed out. Behind closed doors, an internal email circulates titled Public Narrative Consistency. It outlines talking points for interviews: emphasize uncertainty, avoid metaphors, project calm. But the final line gives the game away. In the absence of explanation, control the adjectives. That's the essence of bureaucratic panic, not the fear of the unknown, but the terror of naming it too accurately. If you can't stop the universe from misbehaving, at least you can make it sound professional. Meanwhile, the people at the telescopes keep working, pretending everything's fine, pretending the night sky hasn't become a mirror, pretending they don't notice that 3I Atlas's orbit is beginning to tilt again subtly, confidently, like punctuation at the end of a sentence no one was supposed to finish. And somewhere, in a folder marked Confidential Internal Eyes Only, lies the only honest memo anyone wrote during the crisis. It's 2 lines long. The object continues to exhibit deliberate symmetry. Recommend we redefine deliberate. In private channels, a few physicists are joking softly, nervously. Maybe it's a test, one writes. Maybe someone left something running. Another replies, then who left it? And when? Laughter emoji. Then silence. The kind that stretches a little too long. There's a peculiar tone that creeps into scientists' voices when curiosity and fear start holding hands. It sounds like laughter but thinner, like a wire stretched too tight. You can hear it in those leaked chats from the off-book discussions, the kind that aren't supposed to exist, happening at 2 in the morning, with mugs of coffee that taste like resignation. Someone types, "What if it's a calibration tool?" The reply comes seconds later. For what the solar system? The emojis that follow don't help, because everyone in the thread understands something they can't quite say out loud. The simplest explanation left on the board is the one they were trained never to believe. They've already ruled out natural causes. The chemistry is wrong. The emissions are rhythmic. The orbit bends in self-aware increments. It's not collapsing. It's refining. It acts like it knows the syllabus. So now, when someone jokes that maybe it's a test, the silence that follows isn't awkward. It's reverent. That phrase, "someone left something running," becomes the unofficial motto of the crisis. It starts as gallows humor and ends as hypothesis. The idea that maybe, long before us, something built something, and it's still on, not hostile, not even aware of us, just continuing, like a machine that doesn't know it's been abandoned. One of the chat logs captures a conversation between 2 astrophysicists. "If it's a test, what's it testing?" asks the first. "Obedience," replies the second. Then a pause, and another message. Or maybe curiosity. ESA's internal behavior models don't have a category for curiosity. They do for autonomous energy maintenance, which sounds better on a report. But everyone knows it's the same thing with the poetry removed. You can almost imagine the mood in those unseen rooms. Scientists who've spent careers demanding evidence are now whispering questions they can't submit to peer review. They're not theorizing anymore. They're confessing. "Maybe the universe built prototypes," one of them writes. "We're just one of the ones that learn to look back." Others get philosophical. "If this is a machine," a cosmologist muses, "it's not ours. It's older than stars. It's not a visitor. It's inheritance." Someone else replies, "Then whose inheritance?" No answer. Just the timestamp, blinking quietly. A digital heartbeat marking the moment humanity ran out of categories. Meanwhile, the leak spreads through the back channels of academia like wildfire dressed in caution tape. No one will publish openly, but everyone reads. The theory gains a nickname, the custodian hypothesis. The idea that 3I Atlas isn't a comet, or a ship, or an accident, but maintenance. A mechanism seeded long ago to keep the universe in tune. Think about that. A self-repairing fragment of creation, not intelligent in the way we define it. No curiosity, no personality, just function. Restoring balance wherever physics starts to fray. A janitor of the cosmos. If you were building a universe, Wouldn't you want it to have someone sweeping the corridors? ESA, of course, doesn't acknowledge this, but one of the memos accidentally reveals a section heading titled Thermodynamic Regulation Systems External Influence Models. That's not the title of a document you write, unless you've started to suspect your solar system comes, with maintenance included. In a private voice note that later leaks, an unnamed engineer says quietly, "We always assumed the universe was passive, that it just happened. What if it's self-sustaining? What if we're the bacteria watching an immune cell go by?" Her voice trembles when she says it, not from fear, but from awe, because deep down, every scientist knows how seductive that idea is. A cosmos not indifferent, but self-aware in structure. A place where even entropy gets a supervisor. By now, the unofficial theory has become its own folklore, whispered in academic halls, disguised as metaphor in conference talks, hidden in footnotes. It's the bedtime story science tells itself when the data gets too honest. Maybe the universe didn't stop creating. Maybe some small part of it kept the engine running quietly, eternally, until someone finally noticed the hum. In the last leaked message from that thread, someone writes, "If it's still running, maybe it's waiting for input." No one replies. The chat ends there. The digital silence sits heavy, the kind that feels less like absence and more like listening. And somewhere, far beyond Mars, 3I Atlas drifts precise, patient, indifferent to bureaucracy or belief, following a rhythm older than time. Maybe it's just a rock, maybe it's a relic, or maybe it's exactly what they fear most, proof that the universe left something unfinished, and it's still working. When 3I Atlas disappears behind the sun, it will take our peace of mind with it, because if it returns on a different path, then the sky itself will have spoken. Not in words or symbols, but in the oldest language there is motion, and maybe that's the strangest part. Not that something might be out there, but that it might already be watching us, watching it. You can feel it, the unease that lingers in every observatory, every mission control, every half-finished theory. The screens will go dark soon. The signals fade to static. The coordinates fall out of range. There's nothing to do but wait. And in that silence, the question blooms. What if it comes back different? Science hates waiting. It thrives on feedback, on measurable certainty, on the comfort of things behaving predictably. But now, the people who map planets and measure time are learning what sailors once felt when stars vanished behind clouds, that peculiar mix of awe and dread that whispers, maybe you were never really steering. As 3I Atlas slips behind the sun, telescopes turn away one by one, their last readings archived with the tenderness of goodbyes. The engineers double-check exposure logs. The mathematicians smooth out the final curves. And everyone tells themselves the same thing. It will come back. It has to. But that's the problem with objects that think, or seem to. They ruin the word has to. In the cafes near ESA headquarters, scientists sit hunched over espresso cups like prophets, pretending not to be afraid. It's just orbital mechanics, someone mutters. It'll come out where we expect. No one disagrees. No one truly believes it, either, because for all their data, they know the truth. Every time 3I Atlas disobeyed, it did so gently. Every anomaly was subtle, polite, deliberate, as if easing us into understanding that control was never ours to begin with. The media is quieter now. The hype has burned off, leaving only small headlines and speculation forums. The object's absence feels heavier than its presence ever did. People who never cared about astronomy find themselves looking up at dawn, half expecting something to blink. In private Slack channels, the humor turns brittle. If it comes back in a straight line, one scientist types, "We celebrate." And if it doesn't, another replies. A pause then. Then we start a new branch of physics. No emojis this time. ESA drafts 2 press statements in advance. One for the normal return, one for everything else. The second one sits in a sealed folder titled Contingency Path Deviation Response. It's a masterpiece of calm panic. 1,000 words of reassurance that mean absolutely nothing. Somewhere, in the quiet circle, the secret work group still meets. They talk less now, not because they have answers, but because the questions are getting louder. "If it's steering," says one, "it's choosing." Another replies softly, "And if it's choosing, it's aware." Then silence again. That same stretching silence that follows the word aware. There's an odd tenderness in the waiting, the kind that comes when humans realize they might not be the main characters anymore. What would it mean if something non-biological, non-random, non-human understood trajectory as language? If motion itself could say, "I am here," because that's what's really at stake. If it returns differently, the message isn't about aliens or gods or machines. It's about agency, about the possibility that the universe doesn't just move, it decides. In the nights leading up to conjunction, telescopes catch their last glimpses. The comet's tail glows faintly blue-white, almost tranquil. Someone remarks that it looks like a heartbeat seen through glass. Someone else says, "Maybe it's waving goodbye." No one laughs. The sun swallows it soon after a bright veil of plasma and certainty. And then there's nothing. No signal. No hum. Just the long, ancient quiet of space, doing what it's always done, reminding us how small we are. And still, the question hums beneath it all, steady as pulse. What if it doesn't come back where we expect? What if the curve changes? What if, when it reappears, it's not following our predictions anymore, it's following its own? Because if that happens, the first thing to move won't be the comet. It'll be us, our definitions, our science, our place in the order of things. We'll look at the sky and realize it's not a stage anymore. It's a conversation, and maybe that's the part no one's ready for. Not that something might be out there, but that it might already be aware of the watchers. That our act of looking has become part of the event itself. That, for the first time in human history, the sky might be looking back. So when 3I Atlas disappears behind the sun, what it takes with it isn't just data. It's the illusion of stillness, the comforting lie that space is silent and we are alone in our observation. Because if it returns on a different path, it won't just change astronomy, it will change us. And somewhere, far beyond the sun's burning curtain, something might already be deciding what that answer will look like.